Hey guys, welcome from Bulgaria. As you can see, there is a different place. It took me a while to move to this different place, but I'm happy to be here again with you for a new course, this time in Java. Let me share my screen. And in this course, we are going to talk about JUnit together with Selenium. First, let me first shortly introduce the course module and what we are going to talk in this next few videos. Also, don't forget to subscribe to the Lambda Test channel. There are many awesome videos out there about different technologies. Also, you can check Lambda Test blog. There are dedicated articles about JUnit and Selenium already. And in the next 8 videos, part of this course modules, first, we're going to talk in this particular video about what is JUnit, what are the advantages, why you should care, how to migrate from version 4 to version 5. And we'll discuss the different versions. Then in the second video, we will set up JUnit framework for IntelliJ and install all the dependencies. Also, we'll run tests and execute them through command line and generate reports. Then in the third module from the course, I'm going to discuss various annotations and assertions part of the JUnit library. We will create our first automated test using JUnit and Selenium from scratch. Then I'm going to show you in the next module how to run your tests in parallel using JUnit. Then we're going to create test-driven tests, complex test-driven tests using Selenium together with JUnit. Maybe one of the most exciting parts and modules will be how to run your tests in the cloud using the Lambda Test platform. We're going to talk about what is Lambda Test, the advantages, how to run single tests, or tests in parallel. In the next one, we will review some more advanced capabilities of the cloud execution, such as geolocation testing and others. And in the last module, we're going to discuss a few design patterns, but maybe most prominently the page object model design pattern, together with JUnit. Without further ado, let's begin. Again, Lambda Test is a cloud platform for enabling you to run both manual and automated tests on your website or web apps across many browsers and operating systems. We're going to discuss many of the features of this awesome platform. Now, what is JUnit? JUnit is a popular Java-based open source framework that is primarily used for unit testing Java projects. You can test websites, web apps by performing Selenium automation testing with JUnit. And keep in mind that Selenium and JUnit can be used independently of each other. Through testing with JUnit and Selenium combined helps to write test cases in a more structured way. And annotations that we're going to learn during the course in JUnit are used for identifying test methods, a variety of assertions, grouping tests into test suites, and ease offered in maintaining tests are major reasons for JUnit's popularity for cross-browser testing. As I said, JUnit is free and open source. The JUnit 5 that we're going to talk in this module is the next generation of JUnit. And fun fact, JUnit 5 is the result of a project called JUnit Lambda that actually was crowdfunded by a campaign. And JUnit 5 actually isn't a monolithic thing. Actually, it contains of 3 parts: JUnit Platform, JUnit Jupyter, and JUnit Vintage. Here is the architecture of JUnit 5. And let's first discuss the JUnit platform. The JUnit platform, the first part, defines the test engine API for developing a testing framework that runs on the JVM, the Java Virtual Machine. It provides a console launcher to launch the platform from the command line. plus JUnit 5 based runner for running any test engine on the platform in a JUnit 4 based environment. And there is a first-class support for JUnit in most popular IDEs such as IntelliJ, IDEA, Eclipse, NetBeans, and Visual Studio Code, and build tools such as Gradle, Maven, and Ant that we are going to use in the next module from the course. The second part, JUnit Jupyter, is the combination of the new programming model and extension model for writing tests and extensions in JUnit 5. The Jupyter subproject provides a test engine for running Jupyter-based tests on the platform. And the third and last part, JUnit Vintage, provides a test engine for running JUnit 3 and JUnit 4 based tests on the platform. Here is a simple test structure. The first 3 rows at the top are basically the imports for the libraries. As you can see, the first one is static. Of course, you can use them with asterisks, meaning that you will include all of the methods part of this namespace and basically package. And at the bottom, since we imported the static package, we don't need to write assertions.assert equals, right? And as you can see, this method addition, we're testing the calculator that we defined initialized above. And the important part here is that we marked it with the @test annotation. There is a special module about annotations, but I just wanted to show you a simple structure of JUnit tests. Now, let's talk about the different advantages. First, keep in mind that JUnit has become a standard for testing in Java programming language. It supports, as mentioned, almost all IDEs, so that you can work in any standardized IDE environment. You would find support of JUnit in it. You can also integrate Ant with JUnit to allow execution of test suites as part of the build process, capturing their output and generating rich color enhanced reports. Also, there is a huge library of assertions and annotations that we are going to discuss in a separate module. You can run the tests from the command line and run the tests in parallel. Keep in mind, in next modules, we are going to talk in much more details about it. You can run the test by priority. You have annotations for conditional execution, depending on the operating system and such. Also, you can organize quite easily the tests into test suites. In JUnit 5, the test-driven tests are completely built in. In JUnit 5, again, you can easily create extensions for the platform, and the fixtures allow you to have a fixed environment in which you can check if the results are repeatable. Now, let's talk about the differences between version 4 of JUnit and version 5 and how we can migrate. Let's talk about a few differences. First, JUnit 4 requires a Java version of 5 or above, while JUnit 5 requires Java version of 8. JUnit 5 leverages features from Java 8 or later, like Lambda functions, making tests more powerful and easier to maintain. Also, JUnit 5 has added very useful new features for describing, organizing, and executing tests. For instance, tests can better display names and can be organized hierarchically. Also, JUnit 5 supports all popular build tools and IDEs, while for JUnit wasn't such the case. JUnit 5 is organized into multiple libraries, so only the features you need are imported into your project. With build systems like Maven and Gradle, you can include only the right libraries quite easy. And yeah, JUnit 4 is basically everything is composed and wrapped together. And yeah, JUnit 5 can use more than one extension at a time, which JUnit 4 could not. Here on the next, here you can see basically many annotations have been changed before, now have become before each, after has become after each, before class, before all. All of these changes are to make the tests more readable and easier to write. Again, there will be a separate module that we're going into much more details about the annotations. And now, lastly, let's talk about how you can migrate from JUnit version 4 to JUnit version 5. As you can see, there are a few changes. The first thing is that you need to update imports to remove JUnit 4 and add JUnit 5. For instance, update the package name for annotation test annotation and both the package and the class names for the assertions from asserts to assertions. And don't worry yet if there are compilation errors. Completing the following steps should resolve them. Second, globally replace old annotations and class names with the new ones that I showed you on the previous screen. For example, replace all add before with add before each, and all asserts with assertions, right? The third thing is to update assertions. Any assertions that provide a message need to have a message argument moved to the end, and pay special attention when all three arguments are strings. Also update timeouts and expected exceptions. There is, by the way, a special article on the LambdaTest blog about the migration, so just search on the internet for this blog post. Also, we're going to include it into the resources below. You will find the link. 4, update assumptions if you are using them. And 5, replace any instances of run with, rule, and class rule with appropriate extended with annotations. Again, below you will find the article with all of this explained in much more detail. Hi guys, I'm Anton. Greetings from Bulgaria. Today here is raining a lot. Anyhow, we have time for yet another video from our new JUnit course. So let me share my screen and let's begin. In the first video in our JUnit tutorial for beginners for writing Selenium tests, we discussed what is JUnit, what are its advantages, what is the difference between JUnit 4 and JUnit 5, and how you can migrate. And in our second video from the second module from our course, I'm going to show you how basically how to set up your environment to use JUnit. First, I'm going to show you some prerequisites. Then we are going to run a simple test in IntelliJ IDEA. Then again, the same test in Visual Studio Code. And I'm going to show you in the end how to run the test from command line in 2 different ways. So let's begin. The first, prerequisites. For the prerequisites, first you need to download from oracle.com the latest version of Java JDK. It's perfectly fine to use older version. Right now, at the time of recording, the newest JDK is version 17. Right now on my machine, I have JDK 15, which is completely fine. In order to be able later to run the test from command line using Maven, which is a build system for Java, quite popular, we need to have one special environmental variable set for our tests. It's called Java phone, and how you can check whether it's set properly or not. Basically, we can use the command line command echo Java _ phone with percentages. This is how we can print the actual value of this environmental variable. Right now, it's set to program files Java JDK 15. This is the correct way to set it. Of course, you can use the visual editor if you like. If it's not set correctly, you can type the following command: set x java home and then the path, and you need to surround it with quotes. And again, you should receive this message: success, specified value was saved. And again, you can write whether it's saved correctly or not when you use the echo command. Next, you need to navigate to JetBrains.com IDEA download and download the community edition of IntelliJ IDEA and install it. You need to wait a bit. Of course, I already did that. And when you open IntelliJ IDEA, this is the welcome screen. We're going to click New Project. And from here, from Project SDK, we can choose the proper version of Java which we want to use. In my case, I'm going to use version 15. Now we need to click Next. I need to navigate to the folder of my project. Come on. JUnit tutorial, chapter 2. I'm going to leave it like this. Here we can change the default group ID. Maybe we can leave it like this. It's up to you. And then we need to click Finish. I'm going to create a really simple test for testing a calculator. This calculator will have only a single method called add. And here, this is my project, and this is my module, Java module. In the source folder, we have in the main, we put the classes that we are going to test later during the course. Here we will put logic for our framework based on Selenium and page objects and so forth. And here under the test folder, we put all of our test classes. Right now, I will right-click on the Java folder, and I'm going to choose to create a new package. For now, I will go with JUnit demo, and I'm going to create the same package under the test folder, JUnit demo. And here I'm going to create a simple class that I'm going to name calculator. Add to source control, and this is the implementation. Basically, we have one public method that returns integer, accepts one parameter A, second parameter B, and we are just return the sum of the both numbers. The next thing that we need to create is here a test class where we are going to put JUnit unit tests. I'm going to name this calculator tests. I'm going to add it to the source control. We can click here, I always add to source control. And next, here on top, I'm going to create a private final, which means a constant, calculator underscore calculator. And now it's time to create one test, public void test add, test edition. And here I will create the actual result, which we can get from, we are going to calculate what is the sum of 1 with 1. And next, we need to call assertions dot. However, as you will notice, we don't have the dependencies for JUnit. If you recall from the first module of our course, the latest version of JUnit is JUnit 5. So we need to add a dependency. Again, we're depending on the Maven build system. This is why we have this POM XML. The POM XML basically contains instructions for Maven. Here we can add dependencies or jars to be downloaded automatically on our machine from their main repository, or plugins, and add other Maven commands. Right now, I'm just going to copy the two dependencies that we need. Here they are. JUnit Jupyter, this is version 5. Here for version, we can name just release, which is the latest stable version. And if you recall from the first module, JUnit 5 contains 3 separate parts. So we need the API and the engine so that we can run the test from command line later. Also, in order to run the tests from command line later through Maven, we'll need one more plugin. But when it's time, I'm going to let you know how to do it. Now we return to the JUnit calculator tests, and here we need to add 2 imports above for API assertions. This will give us all of the different methods for asserting things. There is a special method called assert equals, where we first put the expected result and then the actual. And if you recall the simple structure from the first video, here we need to use the annotation test. That's it. We can build the project if you want here from the context menu that you open with the right click of your mouse. Here at the bottom, we see that the build has completed. There are a few ways how you can run the tests directly from here, from the green button. We can run test addition. This will run only this particular test. If we have 2 tests like this, test addition, different numbers. Maybe you can think of better name, of course. Here we can put 3. If you want to run the 2 tests from this class, we can directly run all the tests in this particular class. And as you can see, both of them. Also, you can do it from here. You can click here, run, and so forth. Also, if you want to debug them, you can debug it from here, put a breakpoint, and so on and so forth. Now, we discussed already IntelliJ idea. Let me show you how you can run the same test with Visual Studio Code, which is, by the way, the open source and free cross-platform multi-technology editor from Microsoft. You can go to their website called visualstudio.com. You can download it for Windows or any other system. This is basically the editor. They have different themes, right? Next, you can go to here to manage, and you can go to extensions. In order to support Java, you can search for extension pack for Java. This is an extension that will enable you to have, debugging, running tests. You'll have Maven and language support like highlighting, etc. Right? So you need to install it. Next, you can go to all files, and directly from here you can open the folder, or you can clone it directly from Git. It has built-in support. And as you can see here, because of the extensions that I installed, I already have my Java project. And as you can see, there is full highlight of everything, right? I can run here to run the test. There is a special testing tab that from here I can run the test as well. Completely fine. Everything is running smoothly and really fast. You can give it a try. Now, the last part from our video will be about how to run tests from the command line. I'm going to show you 2 ways. The first one is we're going to use the JUnit platform console runner. Now you can go, of course, all of these links, you can find them in the resources below the video. And also you will, later during the course, when we have more demos, there will be a separate GitHub repository where you can clone the code for all chapters. So you can open JUnit or JUnit 5 docs. And as you can see, here there is a special section console launcher. And it says that we need this JUnit platform console standalone. In order to download it, you need to go to Maven main repository. And we need to search for JUnit platform console standalone. I'm going to type it here. And as you can see, this is the third option. When you click it, you will see different versions. This is the Maven Central. I'm going to download this 1.81 version. I'm going to download the jar. So please download the jar. And next, I'm going to copy it directly to my folder where is my code here. Next, I'm going to open the command line. Here it is. And we can use the following command. java/jar, then JUnit platform console runner, the version, then // class path out. And we need to mention that we need to search for the different build classes inside a particular folder. So we need the command scan class path equal, and then here we need to provide the path. And our path in our example is the following one. Just a second. Here it is. And when we run it, as you can see, there are 2 containers found and the tests are run. And they were executed successfully. This is the first way how you can run the tests. The second way is basically you will need to download from Maven Apache.org download. You will need to download one of these zip files, which contains Maven, and unzip it in program files or whatever you want. Here, I already did that in my program files. I have Apache Maven, the latest version. Again, this was important. This is why it was important to set the Java home environmental variable, because this Maven file here, it uses it, and if it's not set correctly, basically the run will fail. And after you did this, you can use the Maven to build the project, run it, etc. It's really quite easy to do it. Let me show you. We use this command, Maven clean test. And as you can see, a lot of stuff, and we have successful, but as you can see, no tests have been run. What is the problem? The problem is that, as I mentioned before, we don't have we haven't added the plugin needed to run the tests. We need to add Apache Maven plugin called Maven Surefire plugin. One way to do it is you can search for it here. You can search for Maven/Surefire plugin. As you can see, I already searched for it. And from here, you can get basically the thing that I'm going to copy, right? And here in the POM, we will need to add this build section where we have the sections for plugins, and we need the plugin for Maven Surefire plugin. This is the latest version. Then you need again to check to click on the reload button. Everything is in check. I'm going to build my project again. And the next thing again, let's try it one more time. 𝗩𝗚𝗚𝗘𝗢 clean test. And now, as you can see, we have tests. 2 of the tests passed. Build is successful. Now you know 2 ways how you can run your test from command line, which is perfect. Thank you for watching. If you have any questions, you can submit them to and ask them under the comments for the video. Also, don't forget that they're actually on the LambdaTest blog. There are 2 really great articles that can help you. There is a whole section called Selenium JUnit tutorial. As you can see here, we have JUnit environment setup, and here there are a lot of screenshots to help you to set up your environment. Even if you don't use IntelliJ, there are tutorials for older versions of JUnit, for JUnit 4, for Eclipse, NetBeans, etc. So you can check it. Hi guys, greetings from Bulgaria. Today I got inspired for a 3rd video from our JUnit course. I have just finished this awesome book about Java module system, so I got inspired about it. So let's begin. Let me just share my screen. In our JUnit tutorial for beginners, I'm going to warn you how to write awesome JUnit tests together with Selenium, and later how to execute them in the cloud. Till now, we talked about what is JUnit, why you should care, why you should use it. Then I introduce you how to set up your environment. And I was thinking in the 3rd video to talk about annotations and assertions in a combined video. However, I believe that both of these topics are quite huge, as you will see in this video. So in this video, we are going to talk about annotations in JUnit. Let me just, for a couple of seconds, share what we talked about previously. And basically, we had this calculator app that just has one simple method, right, for adding 2 numbers. And here in the JUnit class, I added 2 JUnit tests, and we only needed to mark them with this annotation called test in order to mark them as tests so that we can run them, right? So this was part of our 2nd video. Also, don't forget to subscribe to the channel. There are many awesome tutorials for different technologies. And yeah, click the subscribe button below so that you get notified. And yeah, I created, by the way, below, you will find many links with the different parts of the video. Also, you will be able to download the whole source code, so check the description for more information. So, I created a special for every chapter of our course. There will be a special folder in the GitHub repo. So I created a new folder called Chapter 3. And the first thing that we are going to talk about annotations before writing a simple Selenium test is that, as you know, we need to start the browser, then we need to close it. And JUnit 5 gives us, annotations to mark different methods, to execute logic before all of the tests, before each test, right? And we have these special annotations here. When you create a static method, I call this setup class. I marked it as static, and I put this before all annotation. This means that this method will be executed only once for all of the tests in my test class. When you use the before each annotation, however, as you can see, this is not a static method. This will be executed before each test here, before each test. I need to mark this as test as well. So this method will be executed only once for the both tests, and this method will be executed before each of these two. And of course, we have similar annotations. After each, we will execute after this test, then after this test. Usually, if you want to reuse one browser for the whole test class, we're going to start it here in the before all, and we'll close it in the end. However, usually we want to restart the browser every time. So as you will see in the next chapters, we're going to start the browser here and close it here. And if we need to create some kind of a test data, usually we initialize and create the data here in the database, or we call it web APIs. And then we're deleting it and clearing it in the after all. I put this system out prints to the console so that you can see the whole execution. Now I'm going to run the tests, and as you can see, the before all was executed only once. Then we have two executions of the before each, before the first test and then before the second. The same for the after each, and then we have only once after all. Also, something really important about the test instance lifecycle in JUnit 5. In order to allow individual test methods to be executed in isolation and to avoid unexpected side effects due to mutable test instance state, JUnit creates a new instance of each test class before executing each test method. This per method test instance lifecycle is the default behavior of JUnit 5. And it's similar to all previous versions of JUnit. However, if you prefer that JUnit 5 execute all test methods on the same instance, you need to annotate your test class. This is why I mentioned it. We have a special annotation called test instance. We just need to import this class here and change it to per class. When using this mode, a new test instance will be created once per class. Thus, if your test methods rely on a state stored in instance variables, you may need to reset that state in before each or after each methods. And the per class mode has some additional benefits over the default per method mode. Specifically, you don't need, when you use it, to mark this before all and after all is static. This means that you can use them basically in base classes if you create for the tests, which is really awesome. Also, during this chapter, we're going to talk that basically this meta information, metadata through the annotations basically allow you to configure specifics about the test or test classes. However, there is one more way so that you can put global settings for your JUnit. And we put these global settings here in JUnit platform.properties. As you can see, I already created it. It's empty. And why I mention it? Because there is a special global setting for configuring all the test classes to be in this per method or per class test lifecycle, and you can put it here. It's called JUniter Jupyter Test Instance Lifecycle Default, and then you mention per class or per method. Now, another awesome attribute annotation that you can use, it's called repeated test. As you know, especially when you are creating automated tests, you want to make sure that your test is really stable. Basically, you want to execute it many times to see whether it's whether it's stable or not, whether it's not a flaky test. So you can use this repeated test annotation. Here, this test will be repeated 10 times. Here, I will run it. And as you see here at the bottom, we have 10 types of repetition. Also, you can change the display name. For example, you can change it like this. There is a special setting of this annotation. If we run it now, as you'll see, we have changed a bit the name, or you can create a custom name using this annotation like this: display name, current repetition, total repetitions, or you can have it with underscores as you want, or like this, right? This is again part of JUnit 5. Yeah, we need to make it 10. Let's run it again. And voila, we changed the name, right? Also in JUnit 5, there is a special, another special annotation that allows you to basically change the display name of the tests. For example, like this. This is something totally different. Test. We can name it like this: test addition, different numbers, right? If I run it, here the name will be different. And this annotation is really awesome, by the way, because you can put symbols like this. Or I don't suggest you to do so, but you can even put emojis here, right? It's really awesome. Also, there is JUnit 5 supports custom display name generators that can be configured via the display name generation annotation. And keep in mind that the values put here in the display name annotation always take precedence over the display names generated by this display name generator. Let me show you. As you can see here, I put on purpose, there is an underscore. However, you can rename it like this: display name generation. We put it on top of the class. And there are a few modes. Simple, after the dot, there is autocomplete. There is simple, standard, replace underscores if it's simple, if it removes the trailing parentheses for the methods with no parameters. I'm going to show you the replace underscores. Basically, this will replace the underscore with spaces, right? Let's run all of the tests. And as you can see, there is no underscore now. Awesome. Another really useful annotation that I use quite often is the tag annotation. The tag annotation allows us to mark the tests, and later during the command line execution continuous integration, we can use these tags to filter on specific feature, or the most frequent usage is to mark the test whether they're continuous integration or nightly run, right? Usually in continuous integration, we run the most important tests, for example, 20 of them, and then during the nightly run, only once per day, we're running all of the tests, all of the 1,000 tests that you may have. So you can put the tag on specific tests, or you can directly put it on top of the class. This means that now all of the tests here are nightly run. And also keep in mind that JUnit 5 annotations can be used as meta annotations. What this means? That means that you can define your own composite annotation that will automatically inherit the semantics of its meta annotations. For example, instead of copy pasting everywhere this tag nightly run, you can create a custom annotation called nightly run. And this nightly run can be then used as a replacement for this tag. Let me show you. You will get it right away. So here under Java JUnit demo, I'm going to create a JUnit class dot nightly run. I'm going to add it to source control, and then directly I'm going to copy it. As you can see, it's under the same package. It uses this special syntax that it's basically about creating annotations, and I just put here the tag. And afterwards, how I use it, instead of using everywhere this tag nightly run, I can use directly my new operation nightly run, and directly it will always have this tag there. You can even take one step further by introducing a custom nightly run test annotation that can be used as a replacement for these two, because now I need to put them all together, right? So let's create this nightly run test annotation. Here, I create a new class, nightly run test. I'm adding it to source control. And as you can see, it's test annotation and tag annotation, nightly run test. And now, instead of putting these two, I just need to use the nightly run. I can create a similar one for continuous integration test, right? Now, another useful annotation is the timeout annotation. As you know, many often there are many end-to-end tests that are executing for quite a long time, and we want at some point to fail the test if the timeout has been exceeded. So JUnit has and give you this possibility using this timeout annotation here. For me, this syntax is a bit unreadable. What is this 5 means? It's milliseconds, seconds, right? This is why I prefer to use the another version where I'm mentioning I need just to import. Here we have the value and the time unit. As a time unit, we have hours, seconds. Usually I use seconds. And here we can mention 60 seconds, 1 minute, right? Also, there is a general timeouts for all of the methods. You have specific timeouts for before all, before each, for the different tests that you can put into these general settings. And also you can enable or disable globally these timeouts, for example, if you're debugging something. And you can use this JUnit Jupyter execution timeout mode enabled or disabled. For now, I will leave it to enabled. And also, there is a global timeout for all of the methods. As I said, there is a specific for each one of them. You can check the documentation for this, but we can set, for example, a global timeout of 60 seconds for all of them. Execution timeout default. Now, another awesome thing that you can do is, of course, you need sometimes, as you know, there are bugs, which is because of this, we are writing tests, right, to catch bugs. And sometimes you want to disable your tests when there is a bug. And of course, you can do that using the disabled attribute. By default, you're not supposed to provide a message, but usually the best practice is to put here in a comment, for example, Jira bug ID equal to something, right? You put the bug ID so that you know that this is a bug, and afterwards you can, when the bug is fixed, you can remove the attribute and check whether the bug has been fixed. This is the simplest option. However, there are sometimes tests that, for example, tests that you run on a Mac to test Safari. Then you don't want to execute these tests on Windows, right? So you can use disable on operating system. Here we just need to import static constant. You can use this syntax, disable on operating system Windows, or vice versa. You can just mention enable on operating system Linux or Mac. Also, this is really an improvement compared to other programming languages. Also, there are other conditional execution options. For example, imagine that you want to execute a particular test only for particular test environment, and you put, you can get whether which is the environment from environmental variables. Then you can use this special annotation enabled if environmental variable called env, which means environment, it's stage or staging. Or, for example, you can even write it like this, that it's disabled if it's on a development. You can put here something like regex expressions. And there is one more option. For example, as you know, instead of environmental variables, you can use system properties that you can put here or pass them through the command line. Then basically you can check these system properties. And here, let's imagine that we have continuous integration, whether it's true or not. If it's true, then we're disabling this test also. And the last thing that I'm going to finish this chapter is about running your tests in a particular order. Although true unit tests and system tests typically should not rely on the order in which they are executed, there are times when this is necessary. And then we can use this order attribute. We can mention that this test is executed first, then we execute this one. And also keep in mind that basically to control the order in which test methods are executed, you can annotate your test class or test interface with the test method order notation to specify the method order implementation. Right now, if you want, the default one is the order one, right? So I can mention here test method order. And as you can see, it can be by default is order notation. However, sometimes you can mention that it's the test to be run randomly, which will be really good to, typically, you should not rely on the order in which the tests are executed. But there are times when it's desirable to enforce specific test class execution order. Also, you can, for example, run them in alphabetical order. I don't know why, but you can do that. But as I said, you may wish to execute the test classes in a random order to ensure that there are no incidental dependencies between the test classes, or you may wish to order the classes to optimize the build time. So you can write even your own test method orders, which is really awesome. And of course, there is a global setting that you can, instead of putting everything on top of every single class, and it's called, here it is, it's called test class order default. And as I said, by default, this is called class order annotation. Now, you can check LambdaTest platform. It's really awesome. You can get a free trial. Later during this course, I'm going to show you how to execute your tests in parallel using the platform and use many other awesome features. Hi guys, greetings from Bulgaria, and I'm shooting the video from my new old office because I moved into a different place and I had to rearrange everything. I hope that you're seeing me well. And it's time for a new video from our JUnit tutorial for beginners, combining it with Selenium. Let me share my screen. There will be many exciting stuff in this new video. In the first video, we talked about JUnit and why you should care about it. And we compare it to other test frameworks as well. Then in the second video from our tutorial, I showed you how you can set up your environment and how you can run your tests from the command line. If you miss it, check the description and you will find links to all of the previous videos. Also, don't forget to subscribe to the channel of LambdaTest, because they're each week they're really awesome videos. So you can click it and get notified about our new videos. And also you may check the LambdaTest blog, where there are many detailed articles about JUnit, Selenium, and they're really awesome and long and detailed compared to everything you can find online. So in the third video, it is one of the most detailed videos that I did. We talked about the annotations or the meta information in JUnit. And in this video today, we are going to talk about another important thing in Selenium testing. These are the assertions in JUnit. But also first, we need to write our first Selenium test, right? So let me show you our demo application. This is our demo application, Lambda Test, GitHub IO, simple to do. Basically, this is a web application that simulates to-do application, where you can uncheck stuff, you can add something, and then in our test, we're going to add one new item, and we are going to verify whether it's here or not. And of course, if you refresh, it won't be there. Don't forget, in the links below, you will find a link to our GitHub repository, where you can clone for each of the chapters the source code. You can play with it. And also inside the GitHub repo, you're going to find the slides, but most of the time you won't need them. You just need the code. So let's begin. This is our, from the last time, we have these calculator tests where we wrote JUnit tests, and I showed you different annotations. Right now, we first need, in order to work with Selenium, we need two new dependencies. The first one is, of course, the Selenium dependency. In the POM XML, you need, in the dependencies block, you need to copy this, Selenium, HQ, Selenium Java, and I'm using the new Selenium 4, which was released a couple of weeks ago. We have been waiting for it for a long time. And also, you need one more dependency for downloading automatically for you the needed drivers for the different browsers. It's called WebDriver Manager. And when you paste these two dependencies, you need to click here the refresh button, and IntelliJ will download these dependencies automatically for you. We'll see what this means. I hope that it will be resolved when we run the test. And next, we need to create a new, basically we can copy this class here. I will name it first Selenium tests. I will add it to source control, and we'll delete some of the stuff. I will leave after each. If you remember these annotations, basically this is run before all of the tests inside this class, and also the before each is run before each of the tests, after each after the execution of the tests, and we'll need one test that I'm going to name proper checkbox selected, right? This will be my test. Now, instead of this print and printing on the console, I'm going to initialize the driver and start the browser. And here at the beginning, I will have one private variable to the driver, the web driver, and I'll call this private variable driver. I'm without enter, you need to import the class. Also, I'm going to leave one line. And then with before all of the testing this class, we need to download the proper driver instead of doing it this manually, adding it to source control. No need to do that. Basically, this class WebDriver Manager, this utility class, will do this for you. It will basically detect the version of your browser, and it will download the proper driver. And we need to do this only once. Then, with this line, driver equals new Chrome driver, we will basically here, before each test, we are going to start the Chrome driver. And of course, we need to close it. So we will close it like this. We will check whether it's initialized or not. If it's initialized, we're going to quit. Basically, you're going to close the browser. At some point, you may optimize the tests, but maybe during the later modules from our course, I'm going to show you how you can speed up this a little bit by reusing the driver and deleting some of the cookies. But for now, let's leave it like this. Now, we need first to navigate to the URL of the to-do app, and we are doing this through navigate, and then you need to call to methods and mention the URL as a string. And we need to find, basically, we need to initialize, as I told you, I want to type a date into to-do item. So I'm going to use the Java local date class, and because this is my birthday, I have a birthday soon. So I will use local date, and all of these date-related classes in WebDriver have these factory methods. This is called a factory method. Basically, this static method will produce for you an instance of a local date. And as you can see, we have different options here, and I will use the first factory method. And we need to type the year first, then we need to type the month, and then the day. Now, we need to format this as a string. In Java, we do this through datetime formatter, and I will use the US date format. And then this date time formatter has again of pattern factory method where I can mention the format that we need to format the local date, and I will use this format here. First, the day of the month, then the month itself, and then the year, which is like this. This is basically this format here. It will format the date like this. Next, we need to basically format the date. I will call this date to type is equal to US date format, and then I need to provide the birthday local date, and this will generate a string. And then we need to find the input where I need to type this date. This is the input. Let me inspect it. When you right-click here, you can click inspect, or you can press F12 and use this button here. Let me show you. And here we have an ID, so we can find this input text by this ID, sample to do text. So I'm going to initialize and find a web element, and then I will call it to do input. And I will call the driver find element, and then I'm going to use the by class ID. This is how we are going to find it. And then I'm going to paste this ID. And then the to-do input has a method that is called send keys. Basically, this will type the text, in our case, my birthday, and afterwards we need, of course, to find the add button. Here is the add button, and here we have another ID, add button. So you can use var add button. Var is basically a keyword that represents any type of element. Java will automatically detect the type of the element for you, but I prefer to use it because it makes the code more concise. And here, of course, we are going to use ID. And then you need to call the click method here. Now, after this, we need to find all of the checkboxes. And basically, for example, click the second one. How we can do this? I want to show you one more. As you can see, we can use this ng model attributes. Now let me show you how we can write XPath to find it. As you can see, first we can find these LI elements, and then we can find all of them that has this ng model attribute. So we can say with add, we specify the name of the attribute, ag repeat, and then we can mention that we want to find all LI elements. As you can see, there are 5 of them, but we need to find this input. So we need to write /input. Then if we want to get the text, we will change the input with span. Now, here I'm going to show you another method. I'm going to use again var to do checkboxes equal driver dot. There is another element, another method called find elements. This will find all of the checkboxes. It will return a list of elements, and instead of by ID, I'm going to use by XPath, and I am going to write the XPath that I already did, found. And after that, since as you can see here, if we have you can see that we return here a list of web elements, and I can call here get, and to get an element by index. So I'm going to click the third one like this, and now it's the time to find all of the spans where it's the text here. Again, as you can see, it's just below, so we can modify a little bit the XPath like this, and as you can see, we have 5 results, right? So I'm going to use this XPath here, and I'm going to name this var to do infos equal to driver find elements by XPath. And now it's the time to show you how we can make assertions, because for every test to be a real test, we need to do some kind of verifications. In JUnit, we have this special class called Assertions in JUnit 5. And here there are tons of assertion methods. Basically, this is the verification methods, where you first put the expected result, then the actual result, and most of them you can put some kind of a message to be printed in case of mismatch between them, in case of error. So here I'm going to use assert equals, and I'm going to assert that the proper text has been located in the checkbox that I showed you here. So when I type this date, I want to verify that basically the 5th element by index is with this text here. So we are going to get this text here, right? And assert whether the proper text is there. So I'm going to get the to-do infos. Then I'm going to say, because we start to count from 0. This is why the 6th element is actually with index 5. So here I'm going to type 5, and then we need to use the get text getter to get the text. And this is how we call this method from the assertion. There are many other static methods part of this class that you can use. Maybe another one that it's frequently used in JUnit and you're going to use in Selenium testing is the one that it's called assert true, whether some Boolean expression is true or false. Let me show you. For example, like this. It's a string. This is our expected URL. And we can write something like this. As I said, we can write first, we can check whether the expected URL is equals to the current URL. You can get it by this method here. And as I said, if you hover, you will see that we can put a message. This message will be displayed in case of a failure. So many often we use this assert true. Also, we have the opposite, which is assert is false, of course. Now, another useful method that I frequently use in Selenium testing is if we want to get and verify an array of elements. For example, we can write an assertion to check that all of these items here are present. And I can initialize the expected string array. And I can get all the elements and then use the stream API to map them and use the, as you will see, that there is a special method called assert arrays equals. So we can write the expected like this. This is expected items, new string array, and we can initialize all of the items like this, right? And then again, you can call assertions dot assert array equals. As you can see, there are many overloads of this method that accepts different stuff. We have already a string version of it, and this is why I can write something like this. Actually, I don't have the actual to-do infos. We need to write it. I can write something like this. I'm going to write stream. I'm going to use the stream API. This is something from the newer version of Java. Let me show you. Actual to-do infos equal to to-do infos. Basically, these are all text elements of the spans where this is there. Of course, when we work with it, this is a list of web elements, so we cannot assert directly compare it with array of strings, right? We need to convert it to array of strings, and we can use the stream API. You can check the Java docs, search for it. There are tons of information, and it's quite useful. Basically, you can, through the stream API, you can write, there are tons of methods like map to int, map to string, like count, you have a where, you have a filter. There are many of them, but there is a special method called map where we can extract the information. I'm going to write x, or this is just a temporal variable in the Lambda expression, and I can use get text. Basically, we are going to get only the text from this array of elements, and we are going to put it into a new array. But to do so, you need to call to array method. And basically here, we will extract only the text from all of these spans, and we will return it to actual infos here. And we are going to compare through assertions assert equals. Another useful method sometimes we might use is basically to, for example, if you have a custom test automation framework and you want to write some checks whether it's working properly or not, we may want to check whether your code is throwing a proper exception or not. And in order to show you, you remember our simple calculator. I added a new method called divide, where we are dividing two numbers, and of course we cannot divide by 0. So I'm throwing here a new arithmetic exception. And if we JUnit 5 give us a new possibility to assert whether a particular exception is thrown or not. So I can write something like this. Even I can extract the exception and check the message. So I can get the exception like this. Exception equals assertions, assert throws, and then I need to provide the class of the expected exception. In my case, this is arithmetic exception dot class. And then through Lambda expression, I need to call through anonymous method, I need to call my calculator. In my case, I'm going to initialize a new instance of the calculator and call divide. And I'm going to try to divide 1 by 0. And this will throw, of course, this arithmetic exception. And afterwards, because you have the original exception, and we'll check the whether the type is proper, but here we cannot check directly the message. I can write a second basically a second assertion and assert that this proper text is there in the exception message, because I can get the message from here. I can call the getter get message and check whether the proper message was displayed or not. Sometimes, as you know, when you're writing tests for the web, there are many asynchronous stuff, and many often you have long processes. And sometimes you will want to check that there isn't like a timeout for these long tasks. I already showed you the timeout annotation. However, we have similar assertion. So we can write, you have assert timeout, and we can use here we can use the factory methods of the duration class. Basically, the duration is special class in Java that it's measuring periods of time, right? And there is a special factory method called of seconds, and or of minutes. I'm going to use minutes of minutes, and I'm going to use 2 minutes, and then after that, again through Lambda expression, if we have a multi-line code, not just a single one, here perform your tasks. And if there is a problem, here you will get the proper exception message. Also keep in mind that for all of these assertions, by the way, you can delete the static class, and you can import you can make a static import and make the code a little bit shorter like this. So basically, you will have the opportunity to write without the assertions, but you will have to know what particular what is the name of the assertion method, right? So at the beginning, I suggest you to not statically import the assertions, and when you get used and know that you are going to use these 5 methods, for example, you can do this static import for the assertions. And what else? Also in the JUnit 5, there is a special new class, actually method for grouping for grouping exceptions. And basically this in group assertions, all assertions are executed and all the failures will be reported together. It has an optimal heading parameter which will allow you to recognize group of assertions, and we do that with this assertions assert all, and afterwards we use lambda expressions like this to call the different parts of the code. Like we can have this line here, then we can move the assertion assert false, again like another lambda. You can write comma, you can write many lines like this, right? And all these assertions will be run together and you will get the proper result. But because otherwise, if this fails, basically the test will stop here. But if you use assert all, you will continue the execution. And I want to show you one last thing about the assertions, and actually we are going to write it together. This is a special datetime class. Actually, I'm going to directly show you the implementation of it. Because many times we need to check dates. However, in JUnit and in other similar frameworks, there isn't a proper, a proper method for this. Maybe the closest thing to it is if you need to assert, for example, two doubles in JUnit. If we need to assert doubles and we need to check with some kind of a precision and you want to ignore it, you have a delta assertions, you have a delta, this delta property, right? If we have it, you will see that we have delta. And many often we want to do this for dates. For example, if I have like this, the current datetime, current time, and if we have current time in past, and we have local datetime dot now, and then we say we can say that it's minus minutes, and we can return it 3 minutes. And because many often, when you are testing an application, you need to verify some kind of a date with the time, and we want to ignore parts of the seconds or the minutes or whatever when there is a difference. Again, it's hard to do it, and we can write our own implementation of it. Let me show you. I can add a new enumeration called datetime delta type. You can add a new, whether it's with days or minutes or seconds, as you wish. And then we can create a new class that it's called datetime assert. I will add it to source control, and directly I'm going to show you the code that I wrote before. We have a special static class that it's called assert equals that accepts two local dates, the expected date time and the actual date time. We have the datetime delta type and basically the the delta. This is the count. We're throwing exceptions if some of them is null. And the most interesting part is here. We're basically getting the delta as a duration by the datetime delta type. whether it's days or minutes. We're using again duration of days and of minutes. These are the factory methods. So first we're initializing this expected delta as a duration. Then basically the most important part of the code is this total seconds difference. We're using this math apps, which comes from Absolute. This is a special math library of Java. And we are basically calculating the difference in seconds between the two date times. And afterwards, we are comparing the difference with the expected delta seconds. And if there is a problem, we're throwing an exception. The way we use this in our Selenium tests is right here below. I can call datetime assert dot, and then I can call dot assert equals. First, I'm going to call the expected. I'm going to call no matter. For example, first the current time, then the current time in the past. These are the two date times that we want to compare. Then I'm going to use the date time minutes. Then I'm going to say 3 or 4 minutes difference. If it's in this 4 minutes and the difference is up to 4 minutes, this assertion will be fine. And of course, we need to add an assertion to our method. So this was our video about assertions. I hope that it was useful to you. Welcome guys from Bulgaria. Today we're ready for yet another video from our JUnit tutorial. Let me share my screen. So until now, into our JUnit course, first we talked about why you should care about JUnit. We looked how you can set it up. Then we had a really detailed video about annotations. Then we had a detailed video about all the different assertions that you can do. By the way, don't forget to subscribe to the channel with the ring bell so that you get notified about these new videos for our great Selenium tutorials. And check the Lambda Test blog because there are many awesome articles. And today, I planned first to do a video about parallel testing, but first I believe that we should discuss data-driven testing. And JUnit is a really rich test framework about making tests with parameters. So I will create 2 videos for that, and this will be the first part. So let's get started. Also, you can download, by the way, from the description. You can clone the GitHub repo and get the source code for all the different chapters from our course. And now I'm going to create a new test in order to make it data-driven. I'm going to automate this to do MVC website that basically has the same example, but written in more than 30 different web technologies, from React to Angular. And I'm going to show you how to do this with Selenium in Java together with JUnit. And later in the end of the video, we are going to make a data-driven test with the different technologies. So my test will be first when I provide the name of the technology to open the following link. Then a specific web application is opened, written in this particular web technology. And then, as you can see, it's again a to-do application where we're just adding new items. By ketchup, press enter. Then when you click, it's crossed out. And we want to check here the number of left items. So Again, I created a new project for this called Chapter 5. And in this Chapter 5, I'm going to create a new class, and I'm going to name it to do tests. I'm going to add it to source control, and we will need, of course, we already have everything needed for JUnit. We have JUnit Jupyter API, and later we are going to add one more dependency for writing data-driven tests. And of course, we have Selenium, and we use Selenium 4. And also we need this Maven Surefire plugin to run from command line. But we're going to talk about it later in the course. So now here we need a few private variables. I'm going to add them. We'll have one constant field for mentioning the timeout. We're going to use it in seconds, so 30 seconds. And of course, we need WebDriver. We already have the WebDriver manager dependency, so we are going to open one for the class the browser in this before all method setup class, right? Only once we're going to download the needed driver. And then before each test, we are going to open the Chrome driver, the Chrome browser. So this is why in the before each method in the setup, we're starting the Chrome browser. Also, in order to handle the different synchronization issues and problems in these tests, we're going to use the fluent wait, the WebDriver wait class. And also in order to do advanced interactions like touch or, for example, pressing enter, we are initializing this actions class. And of course, after each test, we're going to close the browser. So we're using this after each method here. Next, I'm going to create a new test method. For now, I'm going to use the test annotation. Later on, we are going to upgrade this test to be data-driven, and I'm going to call it verify to-do list created successfully. Again, for now, I'm not providing any arguments, but later we're going to upgrade it. Our first job is to navigate to this application, the to-do-nbc.com, and then we are going to create a new method where we are going to open the particular technology. I'm going to name this method open technology, and here for now, again, if you return to the application, just to show you what I mean, the name of the technology is this link here. If we inspect it, you'll see here that this is basically an anchor, and we can find it here, basically by the link text name. We have a special locator for this. So here we are going to provide the name of the technology, and this method will be private void open technology. And here as an argument, we're going to provide the technology name. Now, we'll have one helper method directly. I'm going to show you where we are going to use the WebDriver wait. Here we are going to return an element, and I'm going to name this method wait and find element. Here we are going to provide the native biolocator of WebDriver, and I'm going to name this locator. And of course, pressing Alt and Enter, we need to import the class. And here we are going to return the element. Here I'm going to use the WebDriver wait dot. And as you know, we have the until method that accepts a function. And from the Selenium, we have this expected conditions. Expected conditions. And then here we have the method presence of element locator that basically, as you can see from the hover, accepts a bilocator. And this until method will return our web element. From the above, as you can see here, we set this duration of seconds. This is a factory method of the duration class. We instructed the WebDriver to wait 30 seconds until the presence of this element. This is how we are going to mitigate the issue with some of the elements not appearing right away. And here in the open technology method, now we are going to use this method. And here I'm going to name this element technology link equal to wait and find element. And here, as we discussed, we are going to use the link locator. And here we need to provide the technology name. And afterwards, we need to click it. So this is the first name. Then we need another method. Basically, if we return to our application, let's accept that we already clicked this AngularJS. We have this new screen, right? And we need to add a new to-do item. To do so, we need to type it here. Let's see how we can find this text field. As you can see, it's an input. And maybe the unique thing here, as you can see, because it's Angular, it has these specific attributes about Angular. But basically, we can write an XPath to get it by this placeholder. And how we can do this, let's see. If you press in the Chrome Developer Tools Control F, here we can type and test the locators. So I can type input, then with @ sign, I can write placeholder and then equal to basically this placeholder here. And then we can send keys here, and then we can basically work here by ketchup. After we type it, we need to press enter. So I'm going to show you how to do this with the actions class. So right now, let's create another method here that we are going to name add new to-do item. We're going to call it a few times by ketchup. And here below it, I'm going to create it. It will be private void add new to-do item. And here we are going to add the argument to-do item. And we need to find the to-do inputs. As we discussed, again, we are going to use our private method wait and find element. And here we are going to use an XPath. Like this. And then we need to call send keys and type the to-do item there. And then in order to press enter when we're there, first we need to click inside the input. So we have a special click method, but we can click inside an element like this. And since here the actions class implements the so-called fluent interface, another synonym for this is chaining methods. We can chain a few actions, like after we click in the input, we can send keys. Again, and we need to provide the name of the key. In our case, we're going to press enter. Of course, we need to import this class. And at the end, in order to trigger the whole chain of methods, we need to call perform. And now I can add this many times. And afterwards, we want, by providing the name of the item, to check this checkbox right here. In order to do so, let's inspect it. As you can see here, we have a label. So first we can find the label, and then as you can see, we need to use XPath access to find the input type of checkbox and check it. Let's see how we can do that. First, here we can name label, and then we can get the text using another XPath method, text equal, and then we need to provide by ketchup. And then we can use the so-called XPath access. There is, by the way, a really great article on the Lambda Test blog about XPath. Check it out. It explains all of this. Preceding, sibling, and then in order to trigger the XPath access, we use this special operator input. Basically, when you select first the label, we're saying, please give me the top element with this preceding sibling. Of course, we need to mention that it's an input. So we can get this locator, and we can create a special method about it. I'm going to name it get item checkbox. And here I'm going to provide, for example, by ketchup. And of course, we need to create this method, private with element, get item checkbox. So the item. And then I'm going to create a special variable about the 𝗩𝗚𝗘𝗢. 𝗩𝗚𝗘𝗢 equal to, we need to format it, string format. We need to provide the label. Here I'm going to provide it to the item, and instead of this by ketchup, we need to use %s for string. And then here we need to return. Again, we're going to use our wait and find element, and we need to say by XPath and use this locator here. And after we find the element, we need to click it. I'm going to call click. And of course, our last job is to assert the left items. So here I'm going to create a new method called assert left items, where we need to provide it the expected count. And let's see now, private void assert left items, expected count. It's a void method, and now we need to find our, as you can see here, there are two different modes. When it's only one item, we don't have the S. When there are more than one, it's with S. And we need to find it like this. Let me inspect it. Where it is. As you can see here, we have this footer. Under the footer, we have this span. So the easiest way to find it is again to use an XPath where I can say footer span, and then we can check the count. And depending on the count, we can depending on the count, we're going to change the text. So I'm going to find this result span equal to wait and find element by XPath. By the way, depending on the technology, the footer is a little bit different. So this is the correct locator to work in all the different ways. Also, in order to format, we'll need basically this expected text. And what else? Again, the expected text will be different depending whether we have one element or more. So here, this will be the expected text if the count is 1. And we're going to create one more method called validate inner text is, where we are going to use the WebDriver wait. Let me show you in a second. We are going to create this method. And here, of course, we'll provide the same thing. And let's create this method. Let me show you how it works. It will be just a private method, private void, validate inner text, where first we are going to provide the result element, and then the expected text. And the WebDriver wait, again, we call the till method, then the expected conditions, and there is a special method called text to be present in element, where we provide the element and the expected text, and we are going to wait a few seconds until they match. That's it. Let's run it. A build has been triggered, as you can see below, and now the driver starts the browser. We're opening, and we add it, and the test is done. Now, if we want to create a data-driven test about all the different technologies, the simplest way to do it in JUnit, if we have a single, let's call this no params. I'm going to create a second test here that we are going to use a special basically a special annotation. In order to use this annotation, we need to install a new dependency. When you open the POM XML, here at the bottom, we need to add a dependency to JUnit Jupyter. As you know, Jupyter is about JUnit 5 params. Then you need to refresh. And when we return to our to-do tests, the simplest way when you have just a single parameter is to this parameter, for now, it will be the technology that we need to open, technology like this. And here we are going to change the technology. And this new annotation is called, I already created it for all of the different technologies. Let me remind you, the different technologies, I mean here, all of this, depending on the technology name, we are going to click it and then use the same scenario. So first, you need to mark the test as test that it's data-driven with this annotation. And then we have the value source attribute where we need to provide all the different options and arguments that we are going to change here. It's called value source. This works for one parameter, is the easiest way. And let's see. Let's run the test again. It will be run for each of these parameters here multiple times. As you can see here, backbone.js, the first one, then the second one, and so on and so forth. We're not going to wait for all of them to play, but as you can see, it continues to run, and it's going to run for all of them. In the next video, I'm going to show you many other options that JUnit provides for more complex scenarios, like, for example, running tests with enumeration, running them through different methods that accumulate more complex data with more than one parameter, working with CSV files, and many more. So make sure to watch this next video, part 2. Hi guys, welcome from Bulgaria. It's time for a second cup of coffee and part 2 of our data-driven chapter with JUnit. Let me share my screen just to quickly remind you what we did in the last chapter. As we discussed, I decided before talking about parallel testing with JUnit, first to talk about data-driven tests with it. Because there are many available options, as you'll see in this video, I split the chapter into 2. Also, this video is part of our JUnit tutorial with Selenium, part of the Lambda Test course about it. Don't forget to subscribe and click the ring bell so that you're notified about new videos. In the description below, you will find many articles, shortcuts to the part of the video, and also a link to the GitHub repo where you can play with all the examples and download the full open source code. Now, let me quickly remind you what we did before. We created a new example, more complex test, where I showed you how with a single WebDriver test written in Java together with JUnit, we were capable of automating 30 different web technologies such as React, Angular, Knockout.js, and many others. Basically, we're mentioning the name of the technology, we're opening the to-do application written in this particular technology, then we're typing new to-do items, and then we check some of them, and we check here in the test the left item's number. This is the code that we have so far. Basically, at the end of the previous video, part 1, we made the test data-driven, where this test will be run many times for each of these lines here, mentioning the different technologies. And JUnit makes it quite easy to make the test data-driven with a single parameter when we use this value source annotation together with this annotation here above, mentioning that this is a test with many parameters. And we created a few private methods where we open the particular technology every time we are waiting for a new for the element to appear. And then you can rewatch the video. We used a little bit of a more complex XPath locators. Just a quick reminder, if you're not really good at XPath, I suggest you to check the awesome article in the Lambda Test blog about it, and you are going to learn how to write this XPath access and other cool locators that we use here. Now, It's part, as I mentioned, there are many different options depending on what you need in JUnit 5. Just a quick reminder, you need to install this Maven dependency called JUnit 𝗩𝗚𝗘𝗢𝗙 in order to support all of these annotations that we're going to talk about now. Now, here we passed a string. However, JUnit is capable of parsing integers and other simple data types. In order to do so, I just added here a short snippet to show you. We need to import this class, and here, anyhow, you can just assert the number, right? Basically, the whole thing here is that this number here, you can pass int, double, whatever, it's completely fine. Also, you can use these constants here. If at some point, if you need here to pass null or empty string, this is also possible. In order to pass null, you need to use this annotation called null source. And basically, one of the options will supply null. If you need to pass empty string, because here you can just pass empty source. Then for one of the options, for one of the tests, we are going to provide empty string. And if you want to provide both, there is combined annotation called null and empty source. Yeah, basically here is an example of it, right? We can write here assertions, assert is true, and we can anyhow, there is a special string class where we can check whether it's blank or not, or you can just compare it, right? For example, if it's null, we can write it like this. So yeah, basically, if you need in data-driven tests to provide an empty string or no, please use these two options. Next, the next really cool option is instead of listing here, all the technologies, we can create enumeration about them, and we can basically run a single test for every enum value. Let me show you. I'm going to create enum. I'm going to call it web technology. I'm going to add it to source control. I'm going to create one private field called technology name. And I'm going to create a getter and a constructor for it, like this. And afterwards, I'm going to add all the different options, like this. This is really possible. Here we are calling the constructor and we are providing the technology name. And later on, when you use this particular enum, we can get the technology name that we provided here. It's really cool. Let me show you how we can use it and create data-driven tests using this particular option. When we open the to-do tests, I can copy-paste this test. Here, I'm going to just rename it with a num. And here, I'm going to use the web technology. It's fine. And since it's enumeration, here I can call the getter get technology name. Of course, we are no more going to use this value source. Instead, there is another special annotation that comes from JUnit 5. It's called enum source. And here in the constructor of this annotation, we can call web technology.class and we are going to iterate through all of the different options of this enum. Let's run the test to show you that it's working. As you can see, 𝗩𝗚𝗘𝗢𝗙𝗣, this is the enum value. Then we're going to restart the browser and run it for the next tests. Now, it's possible to include a filter for this enum source attribute. For example, just to include just part of the values of the enum. Let me show you how to do so. Enum filter, go to the middle. Here we're going to have the same with enum. Let's name it just filter, right? And now here we need to mention that this is the value, the web technology. Basically, this is the value here mentioning. And then we need to provide the correct names. Names equal then curly brackets, and then we need to include as strings the names of the enum values. 𝗩𝗚𝗚𝗘𝗢, and some of the rest, like this. This will run the tests only for this particular enum values. It's possible to create vice versa the exclude filter. Let me show you how to do it. Exclude. If you want to exclude them, then we need to change the mode. Here at the end, we can mention mode equal to mode dot, as you can see, match all, match any, or exclude. And now we are going to, of course, we need to change the name. Here I'm going to name it exclude. So we are going to run the test for all other enum values, and we are going to skip all of this for. And the last, more advanced version of this annotation is to use regex expression. You can use it for both exclude or include, no matter. And basically here, instead of listing all of the names, I can just mention a regex expression. And right now, I'm going to mention that I want to run the test for all of the values that are ending with JS. It's another option, right? Now, we have an option to run with the so-called CSV source instead of a file. And let me show you how this works. I'm going to copy the first test here. Instead of value source, I'm going to add now more CSV source without file. Basically, we're going to hard code comma separated all of the different parameters inside the annotation. And here, without file. And as I mentioned, I'm going to add, for example, item 1, string item 2, string item 3, string item to check, and we'll have one more int expected left items. Of course, we need to use all of these parameters somewhere in the code in order to make sense. Here we're going to mention item 3 and item to be checked. And here we are going to change 2 with expected left items. And now, instead of value source, we are going to use CSV. CSV, as you can see, there is CSV file source, but we are going to use CSV source. And inside of it, of course, again, we need to provide the curly brackets, and inside the curly brackets, comma separated, we are going to list all of the different options. The first one is the technology. Then, as in a normal CSV file, I will put comma. Then I will provide item 1, the first thing to add to the to-do item. Then the second one, the third one, and what we are going to check, again, comma separated. And the last parameter here, again, separated by comma, is the expected items count. And here, as a new string, we're going to supply the next set of parameters that basically this will be one test. And for example, for technology, we're going to supply backbone.js. Then for item 1, this will be clean the car, clean the house. By ketchup will be item 3. This will be item to check, and this will be expected left items. Then the second test will get this new string. Basically, it will split it by comma, by this separator. Then we will run the test second time. And the third test will use these new strings. If you want to change, instead of comma, to change basically the delimiter, you can do so by adding it here. Right now, by default, it's comma, right? But you can change it. Here, you can mention slash or something else. It's completely up to you. Just in order to use it, of course, you need to use value, right? So you can change the delimiter if you want, if you don't want to use comma. And yeah, for each string here, we are going to run the test one time. If you want to use a real CSV file, it's completely fine. You need to place it here, the CSV file, right, in the resources folder. And again, instead of CSV source, we are going to use CSV source file. And we need just to provide here which is the file, and how many lines we need to. Here, I'm just going to rename it to with 5. So just you need to create this data CSV file here on the resources. And I'm mentioning that I'm going to skip the first line, which is basically the names of the columns, right? Now, more sophisticated way to, and for me, it's maybe even a better approach compared to this CSV files or this complex thing here, because you need to parse in your head what will happen. I prefer to use the so-called method source, which means that we are going to use a special method that is going to produce all of the arguments that you need. Let me show you what I mean. And this time, by the way, first I'm going to use the method source just to simplify this test here with just a single parameter, and then I'm going to show you even more advanced way, better way how you can handle data-driven tests. The first thing is here, I'm going to name this with method. And of course, at the bottom, I need to create a new method that is going to return stream of strings. It should be private, static. It will return stream of string. And I'm going to name it provide web technologies. we need to import the stream class, and then we're going to return. There is a special factory method of the stream.of, and here we need to provide, similarly to how we create empty lists, we need to provide all of the strings here. I already copied them, so I'm going to copy paste them. It's the same way how you initialize lists, right? And now when we have this particular name, we need, let's see where it is. We need to use another annotation called method source. Let's return to the test here. This is without params. With method, here it is. We don't need this value source, right? Instead, I need basically to mention the name of the method, provide web technologies method source. And basically this will call my method below, and we are going to run it. Now, there is more sophisticated way working with parameters. Let me show you. Until now, especially with the many arguments, the test was a little bit dummy, right? The best way to do it is actually here to provide a list of strings for the items to check. Items to check, and list of the items to be checked. Items to add, excuse me, and list items to check. Actually, this is the name of the variable. It's type of list string, and of course, integer expected left items. Now, how we are going to use this? Instead of calling this hard-coded with these three types, here I'm going to use stream API, or basically you can just go for or for each. To for each them and just call this method for each of the items into the collection, but I want to make the test more concise, so I'm going to use stream API to simplify it and write it in a single on a single line. So I'm going to call for each, and here I'm going to name a variable called item to add, and then I'm going to call add new to do item to add. Like this, and then we don't need this three here, and then I'm going to call items to check string for each item to check lambda row get item checkbox item to check. Then I'm going to click it here, right? This way we can basically add any number of items that we put into the method source and basically check the different types, any number, not hard-coded. And here I'm going to change this to expected left items. Now I'm going to create a new method that it's called provide web technologies multiple parameters. Let's see how we can do that. Now, instead of returning here stream of strings, we're going to return private stream of a special class called arguments. And now we are going to return stream of. And here, actually, we are going to call it like this. On the new line, we call arguments, and then we have another special factory method where for each of the tests, we're going to create different set of arguments. Our first argument here will be the technology. In our case, this will be AngularJS, the first one. Then we need, if we return, we then need list of string and then a second list of string and then the expected count. So here we need to provide list of, again, we have a factory method for creating lists. And then here I'm going to mention a different list of items to be added. And then here we need to add a second list of items to be checked, right? So right now I want for my first test just to check these two, by ketchup and by a house. And this means that there will be 3 items left. Then I need to cross the factory method here. Let's see what happened. Yeah, here it is. Basically, this will be the arguments for my first test. We provide the technology AngularJS, then the first list. These are the items to be added. Then these are the 2 items to be checked. And then 3 items are left, because here we have 5, we check 2, 3 items are left, and we are going to assert them. And here I provided a few other lists. Basically, we are going to run 4 tests here. And we need to mention it right here. This is the perfect data-driven tests, right? Now, sometimes it's useful when you create these complex factory methods for arguments. We want sometimes to be able to reuse them. In order to do so, we can basically JUnit provide us with a special class that it's called. Let me show you. It's called arguments provider, and this arguments provider, even before it, actually we can, before the arguments provider, we can create a special class just to reuse it as a static method. I call this Web Technologies Params Factory, right? I'm going to add it to source control. And then basically I copy it and paste it, my method here. I'm just going to make it public. And I can use this method here instead of using the private static method inside my test class, just by using this method source, basically the full classified method name, the package, the name of the class, and then the name of the method. So I can reuse this arguments methods like this. However, I believe this is really ugly everywhere to provide these long strings. And this is why, as I mentioned before, there is another way in JUnit. It's called custom argument provider. So I can create a new Java class called Web Technologies for Technology Custom Arguments Provider. I'm going to add it to source control. And here we need to implement a special interface called arguments provider. I'm going to implement the method. Here it is. We're overriding. As you can see, there is a stream, something that extends arguments. It's a special class. Anyway, inside, we're just copy pasting the return of streams that we used before. And when you have this, basically you can, when we return to the to-do tests, we can use directly this arguments provider now. There is a special annotation called argument source. Here I'm going to rename this as argument source. And instead of providing the name of the method, we need to mention the provider dot class. I actually renamed it. So here we provide the class where our implementation of the arguments provider is. And this is going to run perfectly fine. The next thing that I wanted to show you before we close up the chapter is how you can basically convert dates and other important strings into other classes. For example, imagine that we have a method. Let's say it's public public void. I'm going to call it verify year when custom converter. And here we are going to provide local date, and then int expected. And here I'm going to use the CSV source that we used before. And we are going to call assertions 34 expected date get year. However, without help, JUnit won't be able to convert this string here to a local date, because as you can see, it's something custom, right? It's separated by comma. These are two different tests here. This is the expected year, and this is the year where we need to initialize the local date. In order to handle this, we need to implement argument converter. Let me show you. Here I'm going to create a special class that I'm going to name dash date converter. And we need here to implement argument converter. I'm going to implement the method. Here there is just a check to make sure that we have the correct source or object here. Then this is the logic where we are going to initialize the local date. Basically, I'm converting the object to a string, then we are splitting by dash. And then when we split by dash, I'm getting the three different parts. I'm parsing the integers here, year, month, and day. And then I'm using the factory method of to initialize the local date. Otherwise, we're throwing an exception. In order to use this dash converter, when we return to our tests, there is a special annotation that we provide before the local date. And here I can mention before the local date that I want to use my converter, convert with, and then I need to provide the name of the class, dash date converter dot class. This way we will be able to parse this and convert it to local date, which is really great. Sometimes also, instead of providing so many arguments here, we want to directly create a data-driven test together with just a simple class. In order to be able to create a data-driven test with special classes, let me show you what we can do. I can create a class called to-do list, and I will have these four variables. Then in IntelliJ, I can press out insert. I can initialize a constructor, and then when I select them and press out insert, I can generate getters and setters for all of them. Actually, I want to create a constructor for all of these 4 variables instead of just one. I'll insert. I just forgot to select all of them like this. And then I want to use this to-do list with my argument source provider. Let's go back. Here we have this arguments provider, right? And we want to extend it instead of providing all of these different here. It's to-do list class or with single argument. And here, instead of all of these different arguments, I'm going to use to-do list. And now I want here to use the getter get technology. Then here items to add. To-do list. Get items to check. And to-do list get expected items left. However, in order to support that, we need to implement basically an aggregator. We need to implement the arguments aggregator interface. And I'm going to call this aggregator class to-do list aggregator. I'm going to add it to source control, and we need to implement arguments aggregate. Implement methods. And now, basically, I need to return new list, new to-do list. And then we can get this argument accessor and say there are a few methods. Since our first argument is string, we can use getString 0. Then since we don't have a method directly to get as a list of string, we need to use the get method that it's returning an object. And because this object is actually a list of strings, we convert it like this. Then, since our third parameter is also a list, we need to convert it one more time. And then for arguments, we have a method called getInteger, where we need to mention 3. And now, if we want to use the list aggregator, we can go. Now, if you return to the tests with a single, and now here there is another special, instead of convert with, there is another special annotation called aggregate with. And here we need to provide the name of our aggregator, then dot class. And it's going to work like a charm. And the last thing that I wanted to show you is actually how we can customize the names. I already showed you this in the first chapter, but I'm going to remind you in the context of data-driven tests. Basically, you can, let's say that we want to change the name for this test here. I can use the constructor like this, the brackets, and then I can say name. The index will be, this will be 0, this will be 1, right? This is the special variable index. Then we can provide any display name that we want, and we can access the different arguments with this syntax here. This will access the first parameter, then one will be the second, and so forth. The same way we access them in lists. As you can see, there are many different options depending on your use case. This is why I created basically a second video about this, that it's covering more stuff. And because we have now many tests, like 20 different tests. Hi guys, I'm Anton from Bulgaria, and welcome to yet another video from our JUnit tutorial. It's raining a lot of here, but I believe that we'll manage, and we'll have yet another video. Don't forget to subscribe to the channel of LambdaTest. There are many awesome videos during the week. Hit the ring bell. Also, keep in mind that in the description below, you will find lots of reference articles and a link to the GitHub repo. So without further ado, let me share my screen. Last time in the previous video, we were talking about data-driven tests. I showed you many ways how you can run tests with many parameters, and JUnit 5 is really rich of such features. And today we are going to upgrade our solution and run our tests in parallel. And the next time, keep watching and subscribe to the channel to see a really awesome video how we are going to run our tests in the cloud in parallel. So let's get started. I'll just quickly remind you what we did before. I wrote a test of this awesome open source website to do MVC, where we have the same functionality of to-do list implemented with different web technologies such as Angular, React, and many others. And I showed you basically how you can write a really stable test with Selenium. Basically, the test is just adding different options here, pressing enter, we're checking some, and we're checking this, how many items left. This is our test. Let me show you the code again, and we're going to upgrade the solution to run the test in parallel. So this was our code before. Basically, I used in the first version the value source JUnit 5 annotation, where we listed all of more than 20 technologies, where as a parameter here, and for each technology we have a separate test run. And we have a special method open technology app to open the particular application. The next page, we are adding 3 items, then we are checking the checkbox, and we are asserting what left. And now, if I want to run this test in parallel, in order to do so, sometimes we need to run the same tests in different browsers, right? And I wanted to show you a simplified way at the beginning, and then we'll upgrade it. So I created basically, I copied the test with all of these helper methods at the bottom, where we are waiting for the element to appear, then we are checking everything, we are formatting and validating the text and all of that. So I copy-pasted the code and created these 4 files here, compile time JS to do. Basically, I just wanted to have separate tests for compile time JavaScript libraries. They're just this of them. And I again made a data-driven tests below. Basically, we needed to copy-paste all of the helper methods. And the difference here is that in one of the files I have here initialized the Chrome driver before each test. And also I'm downloading the Chrome driver before the execution of all of the tests in this class. Then we have basically copy-pasted the same class here, but instead of Chrome, we're downloading the Firefox driver. And before each test, we're initializing the Firefox driver. and the technologies and all of the methods here are copy-pasted. Don't worry, in minutes, we are going to upgrade this solution and make it much better and more maintainable. Then, basically, the whole code is almost the same, with the difference here that we have different technologies. I wanted to, as I said, have pure JavaScript libraries, Backbone, AngularJS, React, all of that. And again, in one of the files, we're downloading the Chrome driver, and in the other Firefox driver, we're downloading it and then initializing it. And now, the simplest way to run the tests in parallel is to use JUnit platform properties. And I already added these three properties here, settings. First, we needed to enable the parallel execution. Then we are saying, please, by default, run the tests in a particular class on the same thread in one process. However, we are going to run in parallel all the different classes. However, there will be a problem with WebDriver, most probably. And before running all of this, we are going to basically, we need to reuse some of the code instead of, every time downloading the driver, initializing the browser and all of that, and also make it thread safe, meaning that instead of occurring weird problems with parallel execution. In order to do so, I'm going to create a special class that I'm going to name driver adapter. You can think of the driver adapter as a special wrapper that we are going to use to initialize the driver. We're going to move all the different helper methods like validate inner text, find element, get actions, and all of that. But we are going to make it thread safe. This is the important stuff. Also, I'm going to teach you during the process of two design patterns. One of them is called factory method, and the another it's called template method. The first thing that we will need is to create enumeration called browser. And in the browser enumeration, we are going to use it in order to provide which browser we want to start. And then in the driver adapter, we are going to use it. Now, first thing, I'm going to use a constant for the wait for timeout. Here, private final int wait for element timeout, 30 seconds. Then, in the first thing that we can do is to have a private variable to WebDriver, like this. However, in order to make it thread safe, there is a special class in Java called thread local. This thread local means that we will have this special class. It's something like a container for different objects, and through it will preserve the instance for particular object just for the right thread, the right process, right? And this is how we're going to make our code thread safe. We'll have the same thread local for WebDriver wait, the class that we use for waiting for elements to appear. And we'll have the same for actions. Actions is the class for making a little bit more complex actions like typing on the keyboard, drag and drop, and others. Next, here we'll need to create the so-called factory method. I'm going to name it start. Basically, the start method will be responsible for initializing the driver and starting the proper browser, and again, make it thread safe. Public void start, and here we're going to use the new enumeration browser, and then here we need to initialize all the thread local instances, driver, or let's call it WebDriver, it's fine, WebDriver. And then we'll have a switch statement where we're going to initialize all of them like this. Based on the browser type from the enumeration, we're downloading the proper Chrome driver, and then we're basically adding to the thread safe container the new instance of Chrome. And that's it. At the end, we need to initialize the WebDriver weight and the actions with this thread safe instance. Here it is again. There is a special class set. Basically, we are adding the instance of this object to the thread safe container. Again, we'll have the quit method. You can think of the adapter. As I said, it's a pattern where basically you're adding new behavior, you're changing the names of the methods, and basically changing their public API. By API here, I'm not referring to web APIs, but API when you're designing libraries is about how you name your methods, how many parameters they are, how usable they are, and all of that. And also here I moved all of the methods that we'll further need. Instead of copy pasting them between the different files, we have the quit method. And as you can see now, if we want to get outside of the parallel testing container, thread safe container, we use the get method, and then we're calling quit. Everywhere inside these methods, we first call the get. And then I'm going to create a thread safe getter for the actions, like this. What else? Do we need something else? Probably not. Also, we're going to create a special base class for all of these tests here to reuse the before all, before each, and to provide a getter, thread safe getter to the adapter. So I'm going to create a new class called web test. I'm going to mark it as an abstract because, as I said, we're going to use another pattern. Here I will have the driver adapter. Then what else? We will have before each method, and here now, as you can see, we don't have now this initialize driver. This is the so-called template method that we need to override in each of the implementations of this class, where we are going to call the driver adapter and to call the start method and to mention which browser we want to start. This is why here we provide this get driver. If it hasn't been initialized, we're initializing it, and then we return it. And now let's see how we can use it in tests. Basically, in this Chrome driver, we can extend web tests. And then, as you can see, we are forced to implement the template method. Of course, I'm going to bring it to the top so that it's more readable what we are doing. I'm going to, we no more need all of this. Also, we don't need all of this. Actually, we will need some of them, but let's see. Then, as I said, we'll need get driver start. This is how we start, right? And now we have, instead of wait and find, what else? We have the validate, find and go to URL. Now, here, in order to use it, we need to use the get driver. Go to URL. And here we need to use find element. Now we don't need this validate because we moved it to the driver adapter. Here we need to use the point element here as well. And we don't need anymore this one. And here we have get actions. This is how we refactored our tests really fast. We can do the same for the rest of the classes. However, as you can see, again, we still have many methods here that we are not reusing, right? We'll have a separate video dedicated to page objects. This is maybe the most popular design pattern in automated testing for the web. Now we'll create really simple implementations of it. If I need to tell you what it is, basically for every page, we have a separate class that it's named. For example, this will be our main page, and then we'll have this to-do page for each of the technologies. And here we are abstracting in this particular class, the to-do page, we'll have all of the different elements of the actions that we do, and sometimes we put the different assertions. That's it. And this is how we reuse this code. So I already prepared them, so I'm going to show you. We have the main page. I'm going to add it. And in the main page, we use the driver adapter. We have a constructor to initialize the driver adapter, of course. And I moved here the two methods that are related to the main page. We have open to open the home page, and then we have the open technology app. And then, as I said, we have the to-do app page where most of the logic is placed. Again, we have, maybe you can skip the open, it's completely fine. And then I moved all of the different methods that we had here below because they are related to this to-do page. So I moved them here so that we can reuse them like this. We have the assert left items, get item checkbox, open technology app, add new, to-do item. And the last piece that I wanted to reuse most of the code instead of, again, repeating everything. Actually, next time I'm going to show it. The first thing is that we need to initialize the two page objects. Actually, I'm going to show you. It's called a facade. Facade is basically a special class that contains a workflow combining two page objects or more. And here, what it is. Instead of repeating everywhere, main page open, technology, all of that we had in the test, in the facade, I added through composition the two page objects here, main page, to-do app page. I initialize them in the constructor, and then I have a single method called verify to-do list created successfully. Basically, this is our test, and we provide all of the data that we need, the technology, items to add, items to check, and expected items left. It's the same that we do in the test, right? I'm just creating the workflow here. And if I have to, use this inside here instead of page objects, first I'm going to have a private field to the to-do facade then I'm going to initialize it like this. Since it requires the two main page objects, before each test, I'm creating the facade, new instance of it, and then I'm providing the main page that requires the driver adapter that I'm providing in its constructor, and the same for the to-do app. And afterwards, we no more need all of these methods here. And we need to, now instead of hard coding the data, I will have two lists, items to add, and we are using this factory method of to initialize the list of items to be added and items to be checked. And then we just need to call our facade or the wrapper or the workflow as you wish. So now here we go verify to-do list created successfully. We provide the technology data-driven for the value source and all of the rest. Basically, we will have the same for the Firefox. Of course, here we will have, we need here to extend web tests like this. Here we're starting Firefox, and we will do the same for pure.js. We're extending web test, we're starting Chrome. Here we have different data. The rest is the same. Of course, we can maybe further refactor the code to reuse further some of the code, but I won't do this. And as I said, now we are ready to run the test in parallel. So here we need to mention that the parallel testing is enabled. The default is that we're going to run all the classes concurrently. You need to select all the files that we want to run, right? And then click Run Compile. We're going to run the test from all of these 4 files. Build has been started, and we have a problem. Let's see, what is the problem? Let's try like this. Very simple. Yeah, the browser has been started. Everything is fine. By the way, you can further, here, as you can see, we have in parallel one Chrome and one Firefox. I'm going to stop them now. Also, you can, you have additional options if you want to set how many threads you want to start. Again, we need to enable the parallel execution. By default, we set concurrent, and we can say that we want a fixed parallel strategy. And if you set it to dynamic, then JUnit 5 is really smart to determine how many processor cores you have on your machine, and then determine how many threads it should start. But here, because I know how many cores I have on my machine, I set it to 8. This means that it will start simultaneously 8 different browsers. It's really awesome. It's really cool. It has many options compared to other frameworks. So I hope that this was useful to you. Hi guys, I'm Anton from Bulgaria, and we will continue our awesome JUnit tutorial for beginners. Let me share my screen. Until now, we discussed various topics from why you should care about unit, how to set it up. We talked about the various annotations, assertions, how to run data-driven tests. In the last video, we talked about parallel execution with JUnit. And now the time has come to talk about how you can run your tests in parallel in the cloud using many different browsers. Also, don't forget to subscribe to the channel, hit the ring bell so that you are notified about many awesome videos that we have right now in the Lambda Test channel. Also, check the Lambda Test blog where you will find many awesome articles about JUnit together with Selenium. And also keep in mind that all of the examples that I'm showing you here, you can find them below in a special GitHub repository where you can clone it for free and play with all of the examples. If you have any issues, you can put a comment below the video or write me LinkedIn or raise an issue on GitHub. So without further ado, let's continue with the cross-browser testing. In the last video, I showed you how we were able to run tests in parallel using JUnit. We were capable of doing this when here in the resources, when you enable these settings, parallel enabled, mode default, classes default, etc. Before talking about cross-browser testing, let me explain what this is. And I will give you like a walkthrough of the Lambda Test platform. But before that, as you know, when you type Selenium, not this, Selenium dev. When you go to Selenium dev, you will find the three different tools. The Selenium WebDriver, that is basically the programming interface for the library for interacting with browsers. Selenium IDE, which is extension for Chrome and Firefox for really fast automating some stuff and generating code. And we have the Selenium Grid. Selenium Grid, we use it not for parallel testing, but for distributing tests among different machines. And in order to distribute it, you basically mention which platform you want, which browser, and then the grid is responsible for figuring out on which machine you have the combination between operating system and specific browser version and type. However, in order to handle all of this infrastructure, it requires, of course, the hardware, the maintenance, and all of that. In order to not have this burden, we have platforms like LambdaTest. LambdaTest is one of the greatest platforms for cross-browser testing, where it's basically Selenium Grid in the cloud, or even you can run Appium tests. And you have the dashboard. As I said, in a minute, I'm going to show you how you can run your tests here. You have statistics and filters by tags and everything. You have LT browser, which means it's a desktop application where you can run and test your Android applications on different emulators here directly. Also, you have the real browser where the platform will bring a real operating system with real browsers. As you can see there, all of the different browsers with many different versions, different operating system, different resolutions. If you need to check the responsiveness of your website, this is really great. Also, you can check it on mobile resolutions, and also you can bring a VPN tunnel to your specific local environment to check it out. By the way, we're using on a daily basis in one of our enterprise projects this capability with sharing files and internal websites, running them directly in the platform, and it's working great. Also, you have the visual testing where you can compare different screenshots of your website. But maybe the greatest thing that I'm using on a daily basis is, as I said, the capability of you running your tests in the cloud directly here. mentioning the different versions of the browsers with different resolutions and operating systems. And later on, you can watch videos of your tests. You can check for the errors of the test. You can see all of the Selenium commands with the particular JSON in order if you need to troubleshoot it. Also, you can, if you enable this, you can see the network traffic with all of the requests. This is sometimes helpful when you need to analyze the performance. You can see walks. What are the walks? These are complete walks of, as you know, Selenium is interacting with the browser through just through JSON protocol, right? And also you can download all of the screenshots and the videos. And the platform has integration with many, as you can see, with all major bug tracking software, project managements, continuous integration and continuous deployment tools, communication channels, and all of that. So it's quite easy to integrate. And now it has a really, you can type Lambda Test configurator. The Lambda Test configurator is basically the thing that you need to, as you can see, it supports not only Java, but also C# and all major languages. And basically, this is the tool for helping you to generate these desired capabilities. We need them to, configure the driver to run directly in the cloud. Here is the also in the next video we're going to talk about geolocation. It's really powerful capability of running your tests in a specific country. This is especially important when you need to verify, for example, currencies and conversion rates and many others, or also checking the performance of your website. As I said, you can turn on the tunnel. You can check the network walks. You can run the test in a specific time zone. I turn on the video recording, and here I want to see the console walks. And you can, of course, right now we are working with Selenium 4. So here we have other stuff. Now, let's see how we can make our tests until now. If you recall the previous video, we were using this get driver start to initialize the browser. Here we use this factory method called start depending on the browser. In order to make it more simple, I'm just going to show you. We're going to create another class really fast. I'm going to name it ToDoTest cloud, and then we'll have these private variables here. What else? We won't need to right now the WebDriver manager to download the Chrome driver. Of course, I will need my test, right? Before showing you the initialization. So we have the teardown to close the session. You're already familiar with these private methods here that we use in our tests for the to-do application. We have our data-driven test for all of the technologies. And the main place where we need to initialize everything, again, you need to copy these desired capabilities and paste them. We are going to use the before each method. This means that this will run before each test. We're going to start a session. Then for now, here I'm going to run browser Chrome. Then we need the hash map. The hash map in order to handle, for now, for the secrets, right now I'm getting them through from environmental variables that is called LT user from Lambda Test user, and then I need an access key here. This is the best way to keep them. Then we have build name. You can put whatever you want here. For example, first run in the cloud. This is the name of the build. In order to get the current test name, because they have this capability, we can use this test info object that comes from JUnit, and you can get here the test name. The test name, however, it will be distinct here. When you run data-driven test, there is another method called getDisplayName. The display name is if you recall from the previous videos, we can get this, pretty formatted display name. And afterwards, I already copied the code from Lambda Test documentation. It will be here. We have the platform name, the browser version, the console network visuals, the time zone. Then we're setting the AOT options. That's it. You need it only once. Then we need to format in a try catch. We're going to initialize the driver. We need to add it. Right now, we need to. Actually, we can remove this exception here. It's fine. We need first to format the URL. It is like first is the username, then the access key, then help Lambda Test, and afterwards we need to provide this URL to remote WebDriver, and then we need to provide the capabilities. And of course, below it, we're going to initialize the WebDriver weight and the actions. That's it. That's everything that you need in order to run the tests in the cloud. We can, again, this is quite simple way of running them. However, if you want to mark your tests as passed or failed, we need to do other stuff. There is when you check the Lambda Test documentation, there is a capability for marking the test whether it failed or passed. Otherwise, you cannot figure out without communicating this to the platform. So if we need to upgrade our parallel solution, I'm going to create another method in our driver adapter here. And let me show you. Right now, as we discussed, I already refactored it so that I can quickly show you. I already created an overload of the start method where we are providing the test name, right? Where I'm mentioning again the browser, and by this browser, I'm getting the browser name. How I'm getting the browser name? Well, I upgraded the solution here. We can have here at a string and make it, in order to get the name, we can upgrade it like this here. Let me show you. Here we can have browser name. We can have browser. Here we'll have Chrome. We'll have Firefox, Edge, Opera, And then here you will have browser name. Get name. And now we upgraded the solution here so that we can provide the proper browser name. From the capabilities, if you don't want to hard code them, you can get browser get name. This is a fast way for not hard coding everything. Now, again, this is a special method where we are going to use it in our web test base class in the Дамо. Здравейте. So we need to modify our web test class, and inside the initialize driver, we need to provide the name of the test. And also, I'm going, because in a minute I'm going to show you how to create two extensions for JUnit 5. In order to do so, however, we will have to access our driver adapter. So I will mark this method as static, and also a static the driver adapter. Here we'll need to provide again info to the setup class, and we will get the display name through testinfo display name getter. And now let me show you what I meant by visualizing the exceptions. There is a really awesome article in the Lambda Test documentation called View Assertions, Errors on Lambda Test. As I said, if you want to see the proper error here, the exception, we need to basically execute this JavaScript code through WebDriver. We need to cast the current driver to JavaScript executor and provide the Lambda test exceptions, and then this exception capture, which is a list of all the exceptions that we want to display there. And there is a second thing here. You can find a complete example of it. In a minute, we're going to do it. In order to change the status, as I mentioned, we need to execute this driver execute script Lambda status, whether it's failed or success. So we are going to add this to our library as well. In order to do so, however, to integrate it properly and not put it inside every single class like this in Aftersuit and whatever, because this is just not maintainable, we are going to first create test results listener. This is a way of extending JUnit 5. I'm going to create a new class called test results listener. I'm going to add it to source control, and we need to implement a special JUnit 5 interface called after test execution callback. We need to implement the method here. We'll need just this after test execution context. So for now, I'm going to add a private variable, private static final thread local test result. These test results come from, as I said, from JUnit. Actually, it's not from JUnit, but we need to. It's our enum where we mark whether it's success or failure, and we mentioned here whether the string whether it's passed or failed. And here we will have in the test results listener. We will have the following logic. After we, not here, but above, and then we will have a simple if-else clause. Here, this will be the context. And of course, we will need to extend our get driver adapter to have this execute script method. But basically what we do, first we check whether there is exception. If there is an exception, we mark the current result for the current thread, current process, whether it's a failure or not. And then we're executing the script, whether it was success or a failure. As I said, we need to extend the driver adapter, and I'm going to create a simple execute script method at the bottom. As we mentioned and discussed before, this is a pattern where we are wrapping WebDriver, we are changing the public API or how we access the methods, what are the names, what are the properties. And here I added this execute script where we provide the script, and then we can add as many arguments as we want afterwards. And we are casting it, the current WebDriver, we are getting it from the thread safe container through the get method. And we are executing the script. This is the first way how we can, as I said, add whether the test was successful or not. In order to use this extension, we can put it on top of particular class here that we have tests. However, since we have a base test class, I just need to put it here, and we use the annotation extend suite, and we mention the name of the class.class, right? That's it, everything that you need. And the second thing about the proper way of getting the exception, there is another extension that we can create. I'm going to name this test results logger extension. Again, this is another capability of JUnit to extend the execution of the tests. And I'm going to implement two interfaces, test watcher and after callback. And directly I'm going to paste the code and explain it. The method that we are interested in is called test failed, but basically you can execute logic on test success, test aborted, test disabled. For example, if you want to save a screenshot or a video on failure, if you have started some kind of a recording on a local execution and you're not running tests in the cloud, then your custom video recorder again can save the videos here and analyze what happened. For our purposes right now, to integrate with LambdaTest and add the exceptions, here basically here we get the exception. First, we create an array list of all the exceptions, and we add these calls from the throwable class to get the exception message. And then we just call our get driver. As you can see here, I statically imported the web test get driver so that I can no more need to refer to it like this, web test.get driver, because this is a static class. We can statically import it above, and then I execute the script lambda / exceptions, and then add the list of all the exceptions or messages, and they will be added automatically to the screen, which is really great. And then if I want to integrate this into the whole execution, again, we go to the web test base class and use it through extend with annotation. And depending on your subscription, you can run your tests in parallel in many threads the platform supported. You can run it directly as we did in the last video. So I suggest you to check the platform. It's really awesome. You can check it for free. You can find links at the bottom. Hey guys, Greetings from Bulgaria. Today here is it's getting colder and colder, so it's time for a hot beverage. And welcome to our JUnit course, yet for another video. Don't forget to subscribe to the channel because there every week on the Lambda Test channel there are many awesome videos. Also hit the ring bell so that you get notified about them. In the links below, you can find many useful articles and helpful tutorials. And also all of the code that we are writing in this series, JUnit for beginners with Selenium in Java. All the code examples, you can find them on GitHub, clone the repo, and for each chapter, there is a dedicated folder. So without further ado, let me share my screen and let's begin, because today we have a really interesting topic. Until now, last time, we talked about cross-browser testing in Lambda Test and running tests in the cloud in parallel. And I told you, I showed you many of the awesome features on the Lambda Test platform. And today we'll continue this journey, and we're going to talk about geolocation testing. And of course, we need to talk first, what is geolocation testing? Well, when your server might be in your country or in another, the server is a big machine where your website has been hosted. And when you open the website in a different part of the world, all of the data is crossing big distances, and because of this, there sometimes, for example, if I open my website from Australia, it will be a bit slower compared to if I open it in Bulgaria or United States. So geolocation testing helps us to test our websites from different, or applications from different locations around the world. And the Lambda Test platform helps us to do so by giving us proxy servers directly in the cloud with just a few options. How we can do that? Well, you remember this Selenium Desert capabilities generator from Selenium 4, because this is the version of Selenium that we are using. You can go to geolocations and you can pick whatever country you like. And as you can see here, a new options has been added, geolocation, and this is the code of the country. So you can get, this is the only option that you need. And then when you run your tests, basically it will run in this particular, from this particular location, and you will be sure how much, what is the performance of your website. You can observe the behavior. And in order to demonstrate this, we are going to create a new automation test. I picked this website, GPS coordinates. And when you scroll down, it automatically detects your current location. For obvious reasons, I won't, see my exact coordinates, right? This is why before that, I picked just the capital of Bulgaria, Sofia, with its center coordinates. But when you scroll down, this is going to be refreshed with the current city and country. And our goal will be to get this title here, to get the country, and then navigate to another, a feature of this website called calculate distances. So in our test, we're going to create later data-driven test where for each of the, for example, we will list 10 countries with their capitals, and I will verify each time whether these calculations are correct here, measuring the distance between the two capitals. And in order to do so, I'm going to navigate to this other URL, GPS coordinates distance. I'm going to write the coordinates that was previously detected from the first screen. I'm going to type them here. The capital and then the country. And then I'm going to type data-driven, the second location, click calculate distance, and then verify this distance here. So let's begin. I have already created a new chapter solution here. As you can see, it's just an empty test class extending our web test. If you remember from the previous videos, if you haven't watched it, this is just continuation of what we did. So please go back and watch them. And here we used a pattern called adapter. And in this driver adapter, we have two methods, one that it's connecting to the cloud, and another that is just starting a regular Chrome, a regular browser, mentioning the browser type through enumeration using a pattern called factory method. So initially, I'm going to create just a simple test with a single country. And later on, we are going to upgrade it and run it in the cloud using the geolocation testing. So the first thing that we need to do, if you watched the videos about parallel testing, we use this container, thread container. It's called, we have this static property getter that it's giving me the driver adapter, and inside it, each time, the different drivers are in this thread safe containers. So through get driver, I'm starting Chrome. And next, I need to navigate to the URL, which is gpscoordinates.net. Also, you will notice that I'm going to show you. You will notice that this cookie consent is every time displayed. And if you want automatically to hide it every time without clicking buttons and whatever, the easiest way to do so is through cookies. Let me show you. If we click OK, and if I refresh, you will see that now I have a cookie called cookie consent _ dismissed with value yes. And this is the proper way of handling such things in automated tests. And so we can use, let me see whether I have a cookie method. I believe I don't. Add cookie, no, I don't. So we need to add a new method called add cookie. Here at the bottom, public void add cookie. And here we need to supply the name and the value. And afterwards, we get the driver from the thread safe container. We go manage add cookie, and we set a new cookie with name and value. And here now I have add cookie where we're going to set the two names that I showed you before, cookie consent and value yes. And afterwards, in order this to be applied, we need to refresh the browser. I need to add a new method here called refresh. Public void refresh. This is similar to clicking refresh on the browser. Now we need to call navigate and then refresh. This is coming from this interface here. Also, we will need one more method. As I showed, as I explained, we need to scroll down in order this to be refreshed. And I'm going to change, the behavior of our tests when we find an element to scroll automatically to it, and we can use JavaScript for the job. Next, I'm going to wrap it in try catch block. here I will write catch exception. Element not interactable exception. And we'll just ignore it if this happens. And afterwards, we can use the following code. We'll use JavaScript. With the JavaScript interface, we are casting the current driver. Then we're executing this script where basically we are calling scroll into view true. This will scroll with JavaScript to the particular element. There is another way using the actions class, but in my observation, it's not working pretty well every time. This is why I'm showing you this particular variation. And as I explained, I want every time when we call find element here, after that, so here I'm going to refactor this element equal, and then at the end we will return the elements after we scroll to it. And automatically we will scroll to the elements, which is awesome. Now, if we return to our test, we need now to get the map, and then to assert that the map has been displayed. If you return here, this is the map. So I'm going to start DevTools, and let me see, map canvas. Here it is. So we can find it by this ID here. And this is the map. And then I'm going to assert that the map has been displayed. And the next thing that we need to do is to find this city title here. We will use this ID to get the title. Then we're going to split it by these commas here, and we'll get the country. So again, by title, or you can just use by ID. It's up to you. Then we will get. We will use the getText getter of this address title to get the full address, and then we want to get the last part of it, the country, like this address. Excuse me, address parts. We first need to split it. We use the split method of the string to split by comma, and then we are getting the last tree. And then in order to format the current address, later we are going to exchange Sophia with data-driven stuff here from the annotation for the data-driven test. But for now, we'll stick to Bulgaria, Sofia, right? Current address. And the next thing, as we discussed, is to navigate to the distance page. And there, if you recall, we need first to fill here the first address, then the second. We have just for this text inputs, ID, address 1, address 2, and then we need to find this button here. I guess we can find it by this calculate the distance text. And when we clicked it, let's test it. Sofia, Bulgaria, and then Berlin, Germany. And when we click it, we need to inspect. As you can see, we have a span by ID distance. So we are going to verify this text here. So let's go. First, the first input, we find it by ID address 1. Then we type inside it through send keys the current address, which is Sofia, Bulgaria. Then we find the second address by ID address 2. And then we type Berlin, Germany, and as I said here, we're going to get two values later from the data-driven annotations once we execute it. And in order to get the calculate distance button, we can use XPath button text equal to calculate the distance. And we, in order to work, I tested a few times, and it seems that there is some of a problem because we need to scroll down. In order to scroll down to the button and then click it, we can use the special actions class. We use it sometimes for complex operations and chain of operations such as drag and drop, clicking through keyboard, and other operations. So right now, first we scroll down to the element and then we click it. In order to trigger the whole chain of actions, we need at the end to call perform. This is called Fluent API. And the last part is to find the distance span. If you recall, it had an ID called distance, and at the end we need to call our validate inner text method. If you don't remember, here we are just calling WebDriver wait, and there is a special expected conditions method called text to be present in element. This will wait a few seconds until the proper text is there. And now, if we want to make our test data driven, as I said, we need to refactor the test a bit. I'm going to copy paste it. I'm going to change the test name to verify distance. We are going to add a few parameters: country code, capital, and expected distance. Right now, we are not going to use the initialize driver method. And if you recall from our module about data-driven tests, we can use annotation called CSV source that it's similar to CSV files, but instead of having a CSV file, much more readable is to use directly annotation. So first, I'm changing the display name where I'm going to call it just verify distance from point 1 to point 2, and then each test will be one of these flags. We'll get for the country Germany, then for the country called EE, then for capital Berlin, and then this will be the expected distance. And we'll have basically 8 tests, right? Data driven. However, here we need now to change everywhere, some of the for example, here for Sofia, I'm going to remove it. First will be the capital, then for the country code and from the country, again, we need to modify a bit our start method, because right now we are using the one with just a single browser, but we want to execute it in Lambda Test. In order to execute it in Lambda Test, the first thing is that we here for the test name, we could put a special name, right? And now we want to extend the solution, if you recall from the beginning, to use another option for country code. And in order to use the country code, we will put it below the time zone, geolocation country code. I get the country code from here again, Lambda Test Selenium desired capabilities generator. And now we want to use this method inside our calculate distance. We can do it like this. Verify distance from Bulgaria to country code. directly we are changing the name. And here for the expected distance, we're going to change this method here. Awesome. This is the only thing that we need to do in order to execute the tests inside the cloud. And to run it through geolocation. And here is the result. Let's now start the Chrome just to show you what we are doing. In the next chapter, we're going to talk about page object model in more details, which will be great. The test is green. I'm not going to wait, to run it in the cloud. Hi guys, I'm Anton. Welcome to the last video from our JUnit course. Don't forget to subscribe to the LambdaTest channel. Hit the ring bell so that you get notified about many awesome videos that we upload each week. Also, check below because there are many awesome links there with resources, and you can download all the source code that we are working on during this course from the GitHub repo. And let's begin. Let me share my screen. In the course till now, we talked about what is JUnit. Then I explained how you can set up JUnit environment with IntelliJ and how you can run your tests from command line. Also, if you haven't watched some of the videos, you will find links below in the description. So make sure that you watch everything previously, because I start from the very beginning, but we're working through many advanced topics during the course, and it will be helpful even for more senior people. In the third video, we talked about many annotations, part of the JUnit framework. Later, we talked about the assertions, data-driven tests with many examples. It's a really huge topic. Then I showed you how you can run your tests in parallel, thread safe. And in chapter 7 and 8, we talked about how you can run the tests in the cloud and utilize the power of the cloud, of the LambdaTest platform, and how you can use their geolocation testing feature, which is really awesome. And now, in the last chapter of the course, we're going to talk about the page object model pattern. In short, we mentioned it in the previous videos, but now we're going to look and work in 3 different variations of it. During the course, we looked into this website with to-do applications, basically written in different web technologies. This is our main page where we have the different technologies with their names. And when you click on a particular technology, basically you have the to-do application where you can type to-do items. We check, how many items have left. And why I'm explaining this, because in the page object model design pattern, we are grouping the element sections and everything inside different classes that are basically wrapping all the actions, assertions, and elements for a particular URL, for a particular web page. This is the thing that we are going to do. I'm going to call this screen to do up page, and this will be our main page, right? So let's begin. For simplicity, basically, I removed some of the other patterns so that the code is much cleaner, right? And this is our to-do test class. Basically, we are using WebDriver Manager to download the Chrome driver. Before each test, we are setting we're starting the Chrome browser. If you're using the LambdaTest platform and you want to run your tests in parallel or in the cloud, the place to put everything from Selenium desired capabilities generator, all of this code here, is basically you need to put it here into the before each, and you need to make sure that you close the session in the after each method, basically, which is executed after each test. So this is our test. As you can see, there is much repetition, especially if you need to create many variations of this test with different data. And this is how, and imagine that in many cases we have more than one test class. And this means that everywhere you have to copy paste these methods and locators and everything, which is a pity. And this is why we use the page object design pattern to reuse the locators, to reuse the actions, and to create some kind of a DSL, domain specific language, to make our tests more readable. So I created here, we're going to now use the pattern to make our tests more readable. And I'm going to show you 3 versions of it. This is why I created 3 packages. In version 1, I'm going to create one class that I'm going to name main page. I'm going to add it to source control. And basically for each page for now, we're going as private variables, or this is called composition. We are going to hold instances to WebDriver and WebDriver weight. And we are going to pass it into the constructor. Then we'll have one method called open to open the page. And next, for this particular page, we will have only this method here, and we will need this private method wait and find element. So first, I'm going to copy the private method wait and find element. Don't worry, in the next versions, we are going to make sure that we don't repeat code, but step by step, we're going to improve it so that you understand why we do it. So now I have this public method open technology, and the next thing will be to create the app, to the app page. I'm going to add it again through composition. I'm going to initialize driver, the WebDriver weight, and the actions. We'll have similar open method if you need to open it, and then we will have all of the private methods from our test here, this one, and the validate inner text, because we'll have assertions here. Some people don't prefer to, by the way, to put assertions inside the page objects, but sometimes I find it useful so that you can reuse the exception messages, right? So it's a matter of choice. And the next thing will be to put all of the 4 methods that we used before, to put them here. To have assertion, get item checkbox, open technology, add new to do item. And the next thing will be to create a class called to do page objects with tests. Right here. Of course, we are going to initialize the driver as we talked before. And we will need, of course, after each method to close it. And we'll have before each method setup to start the Chrome driver. So here is the place where we will initialize and start the Chrome browser. We initialize the WebDriver weight with this constant here for the timeout, which is 30 seconds, the actions class. And then this is the place where every time we are initializing the main page and the to-do app page. This is how the test looked. We have all of these methods here, and this is the test without page objects. And now, if we need to change it, it's just, let me show you how it looks with page objects. Basically, again, we are using value source annotation to run it with data-driven. And now, first we call main page open to open the page, open the technology. And as you can see, this is quite readable because you know on which particular screen you are. We are adding new to-do items. If I need to create a new class, I'm just going to use the same page object. If I need to change the locators, I'm just going here. In a minute, we are going to refactor it a bit so that we separate the actions from the elements, because now we cannot reuse these locators here if you need to do with the same element an assertion and an action, and it's a little bit more messy if you don't separate them. But anyhow, as you can see, the test class looks much cleaner, it's more readable. And now in version 2, I'm going to create a base page called web page here in version 2 web page, in order to reuse these private methods here, the wait and find, the validate inner text, also the open method, right? So here first I'm going to add these three. The WebDriver, of course, we need to initialize them in the constructor. Then we need to add getters to them, public getters. The next thing is that I'm going to show you one more pattern. It's called template method. The template method, it's basically a pattern where now if we create a void method called open, sometimes we need to wait for particular, in order to wait for the page to load. Sometimes we can use the WebDriver wait for particular element to appear. And this is why we can add here the possibility for this template method for each child class to override it, and to mention for which element we need to wait there. The next thing will be here, of course, to call the URL. But since this is an abstract class, I'm going to make it abstract so that we don't be able to create instances of it. I'm going to add a protected abstract getter for the URL, so that every child class needs to implement it. And the second thing is the so-called template method, which is basically, as you can see, an empty protected method which every child class can override, so that it can put logic just after opening of the page to load for these particular elements. And the next thing is to move the two private methods from the to-do app page here, the wait and find and validate inner text. But this time I'm going to make them protected so that we can use them in the child classes. And let's see how we can use them. I'm going to create now again main page. I'm going to add it, and I'm going to extend the web page. And of course, we need to add the constructor. And now, as you can see, I don't have anymore the two private variables here for the WebDriver and WebDriver wait. Instead, we are calling the super constructor of the web page, and every time I need to pass the three, the driver, the WebDriver wait, and the actions, we are using the override annotation to override the abstract getter and mentioning the URL. And of course, I will have again the public method open technology. And we'll do something similar for the to-do page. I'm going to add it to source control. I'm going to extend the web page, and we'll have the same the constructor and the implementation of the get URL. And afterwards, we have only the public methods from before without the two private methods. That's it. And now, if I need to show you usage. It's basically if I just copy paste this version, it will basically it will stay absolutely. Of course, here I'm going to change which pages do we use, but the usage should stay the same. However, we are using much more version 2. What is going on? Actions, main page. Yeah, we need to fix the usages here, like that. And as you can see, the usage stays the same, but we reused many of the private methods through these protected methods from the web page, right? Pretty cool, right? And now in version 3, I'm going to show you one more thing. I usually like to separate, as I said, especially here, you can see it now inside the actions, we have everywhere the elements and what we do and how we assert it. I prefer to separate this into 3 files: map, assertions, and actions. This is why I usually for each page create a separate package. I'm going to name this main page, and then I'm going to create one more that I'm going to call view page. And inside the main page, I'm going just to move. I'm going to copy these two. We change the now. What else? The main page will stay basically the same, so I can just copy paste it, which is completely fine. Because here we don't need just for one element to make a separate class, right? You can refactor it as a homework, but I'm going to show you how to do it for the to-do page, which is much bigger. And now I'm going to create a new class that I'm going to name map. Map is basically comes from element map. Many people use it for naming classes that basically hold element locators and getters for the elements. Here we're going to hold an instance again through. We can make it even more abstract to have a base class for the map and for the assertions, but for now we'll keep it simple just to show you the idea. Through composition, we'll hold an instance to the WebDriver weight. And here I will have to move this wait and find element. Again, you can have a base map and put it there. And afterwards, we'll have one getter called result span for the results here. The result span is this thing here. Basically, I created a getter for it, but I'm skipping the prefix get and just call it result span to make the the code more readable. And as I said, we'll have something similar for the rest of the elements part of this screen. One for get item checkbox, or you can name it just item checkbox, and for the technology app. Sometimes when we are building complex locators through string format and using XPath, whatever, it's completely fine here to pass arguments inside the map. And the next thing will be to create a separate class for the assertions. I'm going to name this assertions. It's completely fine for each page to have a map and an assertion because they are in a separate package, so you don't have a name conflict there, right? Again, through composition, we're going to use the map and the WebDriver weight. And we need the WebDriver weight because here we need to move this validate inner text here. Again, you can create a base class for the assertions. For now, we'll keep it simple and I will leave it like this. And I moved here the public method assert left items. What I did here. All right, here I missed one of the brackets. Now it's fine. And now the last part will be how to use this tool inside the page object. I'm going to add it to source control. Again, we need to extend the web page, and we need to import it from version 3. And we need to override it and call the super constructor. And now I'm going to create first, I will create a special getter for the map that I'm going to call map. Again, I'm missing the get keyword from the prefix, and I'm passing the WebDriver weight that comes from the web page. Every time we can create a new map. This is pretty fast, so don't worry. It's completely safe and fast. And we'll create a similar getter for the assertions where we require the WebDriver weight and the map. Basically, here, every time we're going to create it. And the only action method that left action here for do this to-do up page is the add new to-do item. And if we go here, basically we will have to refactor a bit the tests, because right now we are using version 2 here. Yeah, here we need to remove them, and here we are going to use version 3. Version 3, import version 3. And now, as you can see, we don't have now, in order to get this element, in order to click it, we need to call first the map. I'm going to rename this to, as I said, the folder convention. We don't need the get prefix. And in order to call the assertions, we need to call the getter assertions like this. It's up to you whether to make, especially the map public. It may be useful to make it private, but then for each of these methods, you, for example, in order to click this, you have to create a wrapper for them. For example, clicking item checkbox or whatever. So I prefer to, expose my maps public. So it's up to you. And as you can see, it's much more concise, much more readable. So yeah, these were the things that I wanted to show you. This is maybe the most useful design pattern in automated testing. So you need to learn it pretty well, and you need to choose which variation you will use. It was an honor for me to take this journey with you to learn JUnit in Selenium. I hope that these presentations were useful to you. Don't forget to check the LambdaTest blog, because there is a whole written tutorial for JUnit with many awesome articles. If you have comments, put them below the video, or download the source code from the links below. You can put an issue on GitHub. You can find me always on LinkedIn. Feel free to write and chat. And don't forget to get your LambdaTest certification about JUnit and Selenium. Take care. I wish you best of luck in your career. See you soon in other courses.